All right, this is CS50, and this week we begin to introduce web programming. That is still writing code ultimately, but whereby the user interface is now going to be a browser or even a mobile device ultimately. To do that, we're going to introduce you to first some fundamentals of how the internet works itself. Then we'll transition to a language, but not technically a programming language, called HTML, Hypertext Markup Language, followed by another language, though also not a programming language quite yet, called Cascading Style Sheets, and ultimately we'll reintroduce some proper programming so as to automate much of what we'll be now discussing. But first, let's begin with what underlies the World Wide Web, or web for short, which is the internet itself. And it's perhaps simplest to think of the internet as like the underlying plumbing that allows us to get data from point A to point B. So there's lots of computers in the world nowadays. They are all physically connected somehow or virtually connected with wires or wirelessly. And if you can imagine each of those computers somehow being able to talk to one another, that then is our internet, an internetworked set of computers that can somehow intercommunicate. But it wasn't always that way, even though you and I take for granted the fact that we can all talk electronically nowadays online. Indeed, early on, there were only a few points of presence on this here internet. So for instance, here is the United States in 1969 when ARPANET, which was developing what we now know as the internet. And there were only a few locations here, primarily on the West Coast. And those universities initially were indeed able to intercommunicate, sending the first emails, for instance, even before there was a World Wide Web. Eventually, some other universities came online, Harvard, for instance, among them on the East Coast of the United States. And then East Coast and West Coast were suddenly able to intercommunicate as well, as with emails and the like. But in order to get data from point A to point B, so to speak, in this case, West Coast to East Coast, not to mention the rest of the world, once more and more servers were introduced to this mix, we needed to somehow route the information. And so one of our first terms of art today will be that of routers. Routers are simply computers, or technically servers, whose purpose in life is to route information from one point to another. Now, these servers might look a little different from your laptops and phones, certainly. They might look different from your desktop PCs, but they're still just PCs. Computers that maybe have a different form factor, a different shape, but that typically live in what are called data centers, like big warehouses that store lots and lots of computers. Those computers have lots of cables that interconnect them with other computers there, as well as other warehouses and data centers, much like the dots you just saw on the screen. But the software that those servers are running give them the ability to route information from one location to another. So if I here am representing the server, essentially these devices need to decide when they receive some information, an email, a web page, or the like, does it go this way or this way or this way or this other way? And they use software to figure all of that out. Now here we have a visualization in the spirit of using Zoom from some of our former teaching fellows who acted this out. So if you can imagine a teaching fellow named Phyllis wanting to send, say, an email to a teaching fellow whom you might know, in fact, named Brian, well, Phyllis might put that message in some kind of envelope. Here physical, but think of it as virtual as well. And she's going to hand that envelope off to the next router near her. And maybe it's above, below, to the left or the right. But generally, this envelope is going to take some path from point A, Phyllis, to point B, no pun intended, Brian. Let's take a look. Wonderful. So many thanks to CS50's team for making that visualization possible, and how well it worked, getting the data up, down, left, right from Phyllis to Brian ultimately. But how were those teaching fellows, how were those routers making decisions? Well, in this case, we actually practiced quite a bit, but in the real world, it's all dynamically figured out via software in some form. And the language that routers typically talk in order to figure out how to get from point A to point B is a language, or really a protocol called TCP/IP, which is technically two protocols together that each do a little something different. And in fact, let's focus on the one that's probably generally familiar to many of you, namely IP. So even if you're not a computer person, odds are at some point you've heard of IP, perhaps in the context of an IP address. IP stands for Internet Protocol. And you can think of this as a language or a protocol, to be more proper, that computers speak when trying to send information between each other. And a protocol is really just a set of conventions. And so, for instance, in the human world, much of it, if I were to extend my hand to you upon greeting you for the first time, most likely, depending on where you're from, you would know instinctively to reach out with your hand and shake my hand, completing a human protocol. So it's not so much a language that we're speaking, but a set of conventions. And indeed, that's what TCP and IP are. But IP is very specifically focused on addressing servers in the world. So what do I mean by that? Well, it turns out that every computer in the world that's connected to the internet has what's called indeed an IP address, a unique identifier that typically is of this format: something dot something dot something dot something, where each of those somethings is a number, a simple integer. Those integers are typically 0 through 255, which is to say that you have 4 values in a typical IP address that's between 0 and 255. If you're doing some mental math now, you might recognize those numbers. Anytime you're counting from 0 to 255, you're using 8 bits, or 1 byte, which is to say that an IP address, as represented here, with these hash symbols, is 32 bits in total, or 4 bytes. So your mind can immediately start to wander, if you do some of that mental math, to conclude that, oh, it would seem that you can have no more than, per past discussions, 4 billion IP addresses, because 2 to the 32nd power gives us 4 billion, especially if we don't have to worry about negative numbers, which is to imply that there can only be 4 billion devices on the internet in total. Now that's a lot, but there's also a lot of humans in the world, and there's a lot of humans with multiple devices, laptops, desktops, not to mention all of those servers and Internet of Things devices. So the world not only uses this format nowadays, which is technically called IP version 4, there's also a new and improved version of IP addresses known as IP version 6, which the world is starting to use, especially some of the bigger companies and internet service providers out there. But odds are your computer and my computer still tend to use IPv4, this format. So we'll focus on this one, if only because you're likely to see it in the near term in the real world as such. So how does this all work? Well, this is perhaps the most cryptic looking diagram I could find that represents exactly how IP works. Now, this is sort of ASCII art, and this is actually a diagram from the specification, or RFC, request for comments, that defines how IP, the Internet Protocol, is supposed to work. And what this diagram is implying is that anytime you want to send a message over the internet using this protocol called IP, you first have to make sure that you write an address on the envelope, and you write another address on the envelope that is your sender address or source address. And the way you do this, of course, is not something physical in an envelope, but rather you use a sequence of bits that indicates what the source IP address should be and what the destination IP address should be. And then let me wave my hand. There's a whole bunch of other bits being used anytime you send information on the internet, in addition to that source address and destination address. So this, though, is essentially written on the outside of this envelope in this here way. Now, what does that really mean? Well, let me make this a little more concrete. And just for the sake of discussion, suppose that Phyllis, in our example, was sending indeed an envelope virtually to Brian from point A to point B. Then let's suppose, for the sake of discussion, that Brian's IP address is a number like 1.2.3.4. So metaphorically, what Phyllis would do, or really Phyllis's computer would do, is write that IP address right in the middle of the envelope, just like a human would when addressing a letter in the real world. But so that Brian could potentially reply to her, either with new information or at least to acknowledge receipt of this same envelope, she's also going to put her IP address in the top left corner, and maybe her IP address is 5.6.7.8. Suffice it to say, I'm making up these numbers to keep them simple, but they could be actual IP addresses because they fall into that format of something.something.something.something. And so now when Phyllis hands this envelope off to the person or the router next to them, next to her, that router can look at the same envelope, realize, oh, this is going to address 1.2.3.4. I might not be physically next to Brian, that IP address, but I can at least hand it off to some other router that might be closer to Brian and therefore know how to get it to him eventually. And so what routing is all about is exactly that. These servers passing off, metaphorically, these envelopes back and forth, ideally getting them closer to their destination. Now, unlike the real world, where the shortest distance between 2 points is a straight line, you might recall that Phyllis didn't actually hand that envelope up and to the right diagonally to Brian. Rather, it went up and down, and it didn't necessarily follow the shortest path. But in the real world, routers might at least ideally route data in the fastest way possible. So even though they might traverse geographically disparate routes, sometimes because the servers are faster or less busy, it might make more sense to spend a little more distance to get the data there based on how the servers are configured. And also finances might be involved. There's a lot of big internet service providers in the world, the Comcasts, the Verizons of the world in the United States, for instance. They might have relationships with other internet service providers such that they want to ideally keep data on their network so as to not to have to pay fees to route the data on someone else's network, so to speak. So there's lots of ingredients that go into deciding how to get the data from point A to point B. But in general, it doesn't really take more than 30 hops, so to speak, 30 passings of the envelope from router to router, because at that point, it's probably stuck in a loop if it's going on for more than, say, 30 such hops. So what's really written on the envelope is more arcane information like this, but it's just patterns of bits. So it's as though Phyllis was just writing patterns of zeros and ones on this envelope that adhere to this pattern. And then inside of the envelope is what Phyllis might actually want to send Brian. Now, what might that be? Well, as you know, the internet is filled with cats. And for instance, here is one such picture of a very happy cat. Unfortunately, it's a pretty big picture. And if you can imagine this being maybe a video instead, it would be even bigger in terms of its file size, even more bytes. And so what computers typically do is they additionally fragment information when they're sending it on the internet. So rather than try to shove this big cat inside of that envelope, what a computer would do, even though this feels a little sacrilegious, would be to tear happy cat in two, maybe even into 4 parts, and then put each of these fragments inside of an envelope, followed by another fragment inside of another envelope, at which point, to be fair, Phyllis had better address the second envelope as well, probably with the same amount of information. So she would probably put 1.2.3.4 on the middle of the envelope, and 5.6.7.8 in the top of the envelope to indicate that this one, too, is destined for Brian's IP address as well. Unfortunately, once we start chopping things up into fragments like this, it's no longer sufficient for the outside of the envelope to indicate only the destination. Because what if they arrive in this order, or maybe this order, or some other order altogether? After all, there's nothing stopping Phyllis from handing one envelope here and another envelope here, so long as they eventually make their way to Brian. So he's going to need a little more information in order to reassemble this data at its destination and know ultimately just how many total envelopes were sent to him. So how can we go about doing that? Well, let me propose that we introduce another protocol as well that will help us guarantee delivery of this information. So there's this other protocol, TCP/IP, and it's typically written or said in the same breath as IP, such that we talk about TCP/IP, but it's a separate protocol. And TCP's purpose in life is to solve a few problems. For instance, among the problems that TCP does for us is it ensures that we acknowledge exactly how many envelopes were sent. So for instance, on the outside of this envelope, we might write not only the destination and the source address, but I'm also going to say something like 1 of 4 in the memo field of the envelope. We don't often use this in the real world, but if you were to, you could put it down there. And then in the other envelope, I might write 2 of 4. And so that now Brian, upon receipt of that, can see that, oh, this is the second such envelope. And I could keep doing this for number 3 and number 4. And what this allows Brian to do ultimately is not only confirm that, OK, I got pieces 1 and 2 and 3 and 4, he can also infer if he's missing any pieces, lest he have a very unhappy cat that's missing an entire quadrant of that there picture. So TCP accordingly can help Phyllis guarantee delivery by establishing an additional protocol on these virtual envelopes that dictates that we also keep track of the sequence numbers of these here envelopes so that Brian can infer if anything has been missed. Otherwise, he can acknowledge, thank you, Phyllis, I got all 4 of these. But there's another problem that TCP solves for us, which is that the internet itself does so many different things nowadays. We've got email. We've got the World Wide Web. More on that soon. We've got video conferencing. We've got streaming media and so many other applications that run on top of the physical infrastructure that is the internet. So what else does TCP do? It also defines a convention for what we're going to call ports. A port is simply a unique numeric identifier for a specific internet service. And years ago, a bunch of humans decided to standardize what these port numbers are. So for instance, a bunch of humans in a room decided that, you know what, to uniquely identify World Wide Web traffic, let's use port 80. So the number, the integer 80. But if it's securely sent using not HTTP, but HTTPS, more on those also a bit later, then it's going to use port 443. And there's other numbers as well. 25, for instance, is commonly used for email. 53 is commonly used for DNS. And there's other integers as well, much longer list than the two here on the screen. What Phyllis can then do is if she specifically wants to request a web page of Brian, whereby Brian is now not only the recipient, but a web server that has pages of content, what Phyllis can do on the outside of this envelope is add essentially a colon and then a port number, such that now the destination is still 1.2.3.4 colon 80. And this indicates that when Brian receives this envelope, he, as a server, knows that this envelope is destined for not the email server, not the video conferencing server, not the streaming media server, but rather for the web server that happens to be running at Brian's location. And in fact, this is because, as an aside, when we talk about a server, singular, can actually do multiple things. A single server can handle email and web and video conferencing and more. And so what these port numbers ultimately allow servers to do is to multiplex, so to speak, or distinguish which server or which type of service should be handling this inbound request, so that Brian replies with a web page and not, for instance, an email or something that's inappropriate like that. Meanwhile, if we want to get our hands a little dirtier with the underlying format of these things, even though I wrote it on the outside of the envelope as just colon 80, what's really happening underneath the hood is a little something more complicated like this, whereby Phyllis would write not only a destination port, but also a source port. So it turns out even Phyllis uses a unique identifier so that Brian knows how to address his response to her specifically. And there's that sequence number and the acknowledgement number that I alluded to earlier, whereby TCP ensures that we can keep track of 1 of 4, 2 of 4, 3 of 4, 4 of 4. So long story short, what TCP IP together allow us to do is uniquely address computers on the internet, as by using IP addresses in a standard way, and to guarantee delivery of data between 2 points by using these sequence numbers and as well as these port numbers to make sure that the data gets where it needs to go. Now, I'm using guarantee a little bit generously. If the internet goes down, the power goes out, TCP is not going to get data from point A to point B. But assuming the internet itself is working, that is what these protocols together do. But to recap then, with TCP IP, we have this mechanism for addressing computers uniquely, much like we do already in the real world. And in fact, Sanders Theater, for instance, is 45 Quincy Street, Cambridge, Massachusetts, 02138 USA. That is exactly what you could write on the outside of an envelope to mail it physically to Sanders Theater. What we're talking about then with these virtual envelopes is exactly the same idea, but in a way that supports servers sending the same data. And it turns out that just dealing with numbers like IP addresses is much easier than full text like things on the outside of our own envelopes. Indeed, imagine how much happier the mail service, the postal workers, would be if all we were writing were very clean numbers on the outside of the envelopes, and they wouldn't have to read messy handwriting with much more complicated strings of text. All right, so it stands to reason then that this seems to work, at least as I've told it here. But of course, none of us probably use IP addresses explicitly every day. In fact, when you go to a website, you probably type google.com or cs50.ai or other such domain names. And yet, here I am telling this story that underneath the hood, a la Phyllis communicating with Brian, everything uses IP addresses, not to mention port numbers and sequence numbers on the outside of these envelopes. Well, suffice it to say, your Mac, your PC, your phone is somehow figuring out how to write those numbers on the envelope, even though you and I as the humans are only typing in actual domain names like google.com, cs50.ai, and the like. So how does that all work? Well, in the world of the internet, there's other types of servers out there as well. Not just routers that route data from point A to point B. There's also DNS servers as well, domain name system servers. And these typically live inside of your internet service provider's network, or on your university's campus, or in your company's office, or somewhere in between you and the rest in the world. And what a DNS server does, in short, is translate domain names to IP addresses so that you and I, as humans, can type the more user-friendly version of google.com and cs50.ai, and you and I don't have to worry about or figure out what the underlying IP addresses are. Now, it turns out the implementation of a DNS server follows a familiar paradigm. We've long talked about dictionaries now, an abstract data type that allows us to associate keys with values. Well, in the case of a DNS server, they essentially have inside of their memory a 2-column sheet or table, the first of which is the domain name, the second of which is an IP address. Technically, those domain names are called fully qualified domain names because it might be something like google.com or www.google.com or some other subdomain therein. So what it is you type would be in the left-hand column here, and what it is that gets written on the envelope would be in the right-hand column here instead. So now this table, you could imagine it being very, very big. I mean, there's thousands, hundreds of thousands, millions of domain names out there nowadays. And surely your phone in your pocket doesn't know about all of them. But that's OK, because the design of DNS is actually to be very hierarchical, so that your internet service provider probably has its own DNS server that can translate many domain names to IP addresses, especially if they're popular ones, and therefore they have looked up the IP address already in the past for their customers. But if you visit a random website that's not very popular and no one has visited at all or recently, your internet service provider can recursively ask another DNS server for the answer to the question, what is the IP address of that domain name? And in fact, around the world, there are what are called root servers, a small number of servers that, for instance, know about all of the .coms and all of the .orgs and all of the .govs, and similarly for other countries as well, whereby those servers, even if they don't know the exact IP address, they might know the IP address of another DNS server who does have the answer. And so long story short, if you've ever bought or really rented your own domain name before, or if that's something you choose to do in the future, essentially what you're doing when you pay someone some number of dollars per year to buy a domain name is you're asking them to add an entry to their DNS server or someone's DNS server that associates that domain name henceforth with a specific IP address of your server or server. So someone somewhere is doing that for you. But the whole process is indeed recursive, because if your ISP doesn't know the answer, it can maybe ask another DNS server, or maybe these root DNS servers as well. Your own Mac, your PC, your phone might itself cache or remember these answers though too, because it's a little silly in terms of design if your phone or your laptop or desktop has to constantly ask that same question every time you visit google.com. Odds are the IP address is not going to change, or at least it's not going to change that frequently. However, again, if you've ever set up your own domain name, if you've ever moved it around or something has changed about it, sometimes you can break a website by changing its IP address, because there's lots of servers in the world that have cached, C-A-C-H-E-D, or remembered the old IP address. But thankfully, the other feature that DNS provides is expiration dates. So essentially, the answer to the question, what is the IP address for this domain name, typically expires after a few seconds, a few minutes, a few hours, a few days. Unless you really mess things up and say, don't expire this for a year, then your website could in fact be a dead end somehow. So this is worth knowing for future web developers doing things in the real world. So DNS, to recap then, simply converts domain names to IP addresses, and technically can go in the other direction as well. And so when you, as a human, go to a browser on a laptop, desktop, or phone and type in google.com, enter, or cs50.ai, enter, what essentially happens is your device checks its local cache to see if it's already been asked that question before. And if it has, it just immediately knows the IP address, writes it on the outside of the envelope, so to speak, and sends out your data. If it doesn't know the answer, your computer is going to ask the local DNS server, which might ask another DNS server, which might ask another DNS server. But recursively, you will eventually get your answer if that domain name actually exists. And at that point, your computer can indeed write the correct IP address on the outside of the envelope, add any sequence numbers, add any port numbers, and voila, it's on its way from point A to point B. So that then is DNS. How about one other acronym that's a bit related here too, that of DHCP? And let me assure that it's not really that important to memorize like what all of these acronyms stand for, but rather it is useful, I think, to generally know what they in fact do. So DHCP is Dynamic Host Configuration Protocol. So there we have it, another protocol, a set of conventions. And the purpose of DHCP is to actually give your computer an IP address when it boots up. This wasn't always the case. Back in the day, if you've had internet connectivity for a while, some technician probably would come to your house when you or your family signed up for internet service. They would probably have a sheet of paper on which was your personal IP address. And if you wanted to connect your PC to the internet, they would like type that IP address manually into your computer so that your computer knows what IP address to use when talking to other servers. That's not particularly scalable. That's not particularly maintainable. You don't want the technician to have to come out just to make a change or something like that. And you probably want to be able to use multiple devices as well. And so nowadays, what most computers use is DHCP to dynamically figure out what is their IP address. And so nowadays, when you first open your laptop in the morning or boot up your PC or take out your phone, if you haven't used it in a while, and therefore it no longer has an IP address because these two expire after some amount of time, your phone, your device will broadcast a message like, "What is my IP address?" And hopefully, on the nearby network, in your home, in your company, at your university, or in your internet service provider more generally, you will hear an answer, oh, use the IP address 5.6.7.8. For instance, in the case of Phyllis, or 1.2.3.4 in the case of Brian's recipient address as well. So the people who run these servers, the internet service providers of the world, the system administrators at your company or campus, they can come up with the rules via which these IP addresses are assigned or who gets what number. But ultimately, DHCP is just another protocol that governs how your device gets its IP address. But that's not quite everything. It's actually kind of neat. DHCP servers also tell your computer what DNS server to use. They give you the IP address of one or more DNS servers to ask questions of. DHCP servers also tell you the IP address of your default gateway, the router that you should use by default to hand one of those envelopes to. And this is indeed why Phyllis probably knew to whom to hand that envelope in the first place, because when she booted up, so to speak, she was assigned an IP address, she was told what default gateway to use, and the default gateway, aka router, these are just synonyms, is the device to which she should hand off data by default in order to get it from point A to point B. So why do we focus on all of these acronyms, all of these technologies? Well, on the one hand, they're sort of omnipresent. And even though you might not need to say these acronyms verbally all that often, you're going to see them on occasion. When something goes wrong, you're going to need to troubleshoot things like this. But more importantly, they're sort of representative of very real-world engineering problems that the world has had and encountered over the years. But they're relatively simple solutions there too. You know, I don't necessarily know how I could write code to implement a DNS server or DHCP server, and perhaps neither you, but it sounds like a pretty simple idea. If I have the ability in code to hear requests, I can respond to those requests by maybe using a dictionary in memory, and in the case of a DNS server, and responding to those answers. So this is to say all of the fundamentals, all of the ideas we've been talking about throughout CS50 really are used as building blocks to solve these very real world, very omnipresent technologies that you and I now take for granted every day. Let's now consider one other protocol that's with us every day nowadays, that of HTTP, Hypertext Transfer Protocol, which is indeed itself a protocol, a set of conventions that governs, in this case, how web browsers and web servers intercommunicate. It is very much related to HTTPS, which is literally the secure version thereof, that somehow uses encryption, somehow scrambles the data to ensure that when you're visiting a web page, you and only you can see that web page, and no one in between you on the internet actually knows what it is you're looking at or the specific URL that you are visiting beyond the name or the IP address of the website itself. So even though you and I probably don't even bother typing http:// or https://, odds are nowadays you and I just type google.com, enter, cs50.ai, enter, or you click on a bookmark. Underneath the hood, this protocol is everywhere, and those prefixes, http and https:// are required when using a browser, even though your browser automatically tends to insert those prefixes automatically if you, the human, don't bother typing them yourself. So they're used used, of course, in URLs, Uniform Resource Locators, which specifically are the addresses that we use to get to useful information on the World Wide Web, or web for short. Here, for instance, is one of the simplest URLs we can talk about. I'm going to use HTTPS deliberately to imply that you really do want to try to use secure sites alone nowadays. But this domain name would seem to be www.example.com, or that's the fully qualified domain name itself. But let's tease apart what's going on here. Typically, in your browser, you might see a trailing slash, so a forward slash at the end of it, which just indicates, albeit non-obviously, that you want the default web page at that domain name. In particular, you want to be able to access whatever the default content is for that website. Nowadays, though, browsers like Safari and Chrome and even others tend to hide these details just to simplify what you're actually seeing in your browser. But typically, if you click or double click on the URL bar in your own browser, you'll see more information, including this trailing slash. So if you only type in google.com, enter, probably your browser is automatically appending the forward slash to indicate you want the default home page. But sometimes there's more to the URL. Sometimes it's slash path, where by path I just mean a folder or a file name or something along those lines. And that's more specifically referring to like probably a directory on the server containing some web page specifically. Sometimes it's more explicit. Sometimes the URL might literally end in .html, which is going to stand for hypertext markup language, one of the first languages we'll soon look at in detail. And that's the language in which web pages are written. So what this URL indicates is that at the server called www.example.com, there is a file called file.html that this user wants to see in their browser. Sometimes, though, and it's not often the case anymore that you see these file extensions. The world decided years ago that these are just kind of ugly and not strictly necessary technically. So sometimes you'll just see slash folder slash, which just means there's a folder, aka directory somewhere on the server, whose web page content you want to see. Sometimes it's nested. Sometimes it's a folder and then a file inside of which is the web page contents that you want to see. So in short, URLs generally follow this kind of format. And there might be 0 or more of these folders and maybe a file name explicitly or not. But what else is going on here? Well, here we have the fully qualified domain name. And just to toss out a bit more jargon, technically when you say domain name, typically you mean something like this, just the example.com. Because the www in this context is generally referred to as a host name. It's like the name of a specific server at a company, at a university that is providing some service like this, the World Wide Web, aka a web server. It is not strictly necessary for a server to have a name of www just to be a web server. For many years, MIT's website was web.mit.edu, whereas everyone else in the world was using www. But odds are many of you are probably not even in the habit of typing www.something.something. Rather, you type in google.com and hit enter, and the browser somehow automatically brings you to www.google.com. So the host name is the name of a specific server. The domain name is typically just something like the example.com. And let me disclaim, that's a bit of a white lie, because if you're Google, if you're Meta, if you're any of these big companies, you don't just have one web server. So technically, the www refers to a collection of servers. Maybe it's 2, maybe it's 20, maybe it's 20,000 servers. There are technologies that allow you to support that as well. But lastly, there's one other piece of jargon that's worth knowing. The last part of these fully qualified domain names is known as the TLD, or top level domain. And that is what generally, historically indicated what type of domain it is. In the US, .com means commercial, .gov means government, .org means organization. However, there are so many more top-level domains nowadays, and in fact, they're not US-centric. And in fact, just because you have .com does not mean you are in the US. It just means that you paid someone to use their domain name. In fact, there's other TLDs too. Every country has its own .us for the United States, .uk for the UK, .jp for Japan, and so forth. Anytime the TLD is just 2 characters, that's a country code. And yet that's kind of curious because we're in the habit of using CS50.ai. There are websites that use .tv. There are websites that use .io, CS50 included. And if you'd like to go down that rabbit hole, feel free to Google top-level domain, or TLD, and any of those. And you'll actually see that even though we are using CS50.ai to imply artificial intelligence, .ai has nothing to do with artificial intelligence, except that that is how you can abbreviate it in English as an acronym. It actually is a 2-character country code. And that country and others have decided to actually monetize the TLD by selling it to really anyone who's willing to pay per year to use that there TLD. So lastly, within these here URLs, we, of course, have the actual HTTP or HTTPS, and that dictates the protocol that is going to be used when a web browser requests a web page at that there address. Now, what does this protocol do? It's similar in spirit, again, to sort of a handshake, whereby a web browser, when it wants a web page, it's kind of like extending a hand, hoping that the web server will respond and know what to do. Of course, there's no such handshake physically here, but rather, metaphorically, the web server should know how to respond so long as the web browser standardizes the message that it sends. So what do I mean by that? Well, let me propose that inside of this envelope can be one of two messages. And this is a bit of a simplification, but the first of those messages is get. And what get means is literally get me a specific web page. By contrast, you can use post inside of these envelopes, and post generally means to send information somewhere else. And this too is an oversimplification, but generally the word get is used by a browser when it just wants to get information. The word post is used when it wants to send information, often sensitive information like a credit card, an email address, a password, or anytime you're sort of filling out a form, it's generally sent via the post keyword instead. And these are indeed verbs, like get and post are both verbs in English, implying that this is some here action. Now, ... means that there's other verbs that can be used inside of these envelopes as well, but let's be more specific. Inside of the envelope that's being sent from browser to server is more specifically a message like this. So if I, with my browser, visit www.harvard.edu, the message that goes inside of that virtual envelope, as we discussed earlier, is literally text that looks quite like this. So the cat is gone. There's no more pictures of cats just yet if you're just requesting Harvard's own homepage. But inside of that envelope is indeed get/http/to, for instance, then host, then the actual host name or fully qualified domain name that you are seeking. And ... There's some other stuff there, but that's what's inside of that envelope. Hopefully, what's going to come back from the server is another envelope inside of which is a response. So whereas the first message is a request to get something, the response is indeed a response that hopefully contains the actual web page that you requested. And you'll see that the response might look like http/to, 200, and then content type text HTML, which just means that the web page is written indeed in this language we're about to spend time with today, HTML, below which is the actual content. So how can I actually go about seeing some of this? Well, let me actually go over to VS Code. And up until now, we've been using VS Code for the purposes of writing code. But we do have this terminal window. And the terminal window gives me access to an underlying operating system. That operating system, recall, is called Linux. And I have a command line interface here. And up until now, I've been using this command line interface for commands like cd and ls, make, debug 50, Python, SQLite 3, and the like. But there's other commands that typically come on a system, including this one, that allows me to make internet requests as well. Not even with a browser, but textually. Moreover, there's always been, even though I generally hide it during class, a second tab, namely ports. And if you yourself look at cs50.dev after logging in, odds are you will see a ports tab, among others. And what you'll see here is that all this time, CS50's own development environment has been using by default a TCP port number, namely 1337, which is a very elite number for us to use. And that is the port number that's used by CS50's customizations of VS Code. Our so-called extension uses that TCP port number so that when our extension is talking to VS Code, it uses a standard port number on the outside of its own virtual envelopes, if you will. You as users don't need to care about that, but that's why that tab, all this time, if you've seen it, has had numbers in there. And soon we're going to see some additional numbers as well. But if I go back to my terminal window here, I, of course, could type commands. And one of the commands I could type is actually this. Let me increase the size of my terminal window. Let me go ahead and type curl, which means connect URL, -I. And now let me go ahead and type in https://www.harvard.edu/. So I'm going to manually type this into my terminal Windows command line interface and see what comes back. I'm going to hit enter. And I get a bunch of stuff back. That's why I used a ... on my slide a moment ago. But in this output is some familiar text now. One, we saw this line earlier on my slide, http/to and then some number 200. And then there are other lines here that I waved my hands at earlier because they weren't strictly necessary, including the host line. If this server is only doing one thing, we don't even need to clarify that this is www.harvard.edu. But what then is this HTTP/2 and this 200? Well, it turns out that the 2 is just a version of HTTP that my browser or my keystrokes were using a moment ago. 1.1 is a common version number, 2 is a common number, 3 is catching on over time. But this just indicates what version of the protocol the browser and server are speaking, even though this browser has no graphical user interface. It's just a command simulating a HTTP request to get back these headers. And that's in fact what -I means. Show me just the headers. I don't want to see any cats or Harvard news. I just want to see the headers inside of the envelope. But it turns out all this time, for as many years as you've been using a browser, you could actually do this in your own browser as well. Let me open up another tab here, and let me manually go to https://www.harvard.edu/enter. And what I'll see here is Harvard's homepage as of right now today. It all worked as you might expect, but it turns out all this time you've had access to some powerful tools underneath the hood. Let me actually right-click anywhere on this web page and select Inspect. And that's going to open what are called developer tools in the context of my browser, which is Chrome. Most every browser nowadays, Safari, Edge, and others have similar looking tools, though you might have to access them via different menus. And in fact, in Chrome, you can also go up to the ... menu and find your way to developer tools. But there's a lot going on here. But what I'm going to do is go to the network tab here for a moment. And I'm going to zoom in just for the sake of legibility. And notice here that when I clear this network tab, this is giving me access essentially to a log of everything that you're about to see on the screen. And notice it just undeleted itself. Apparently, Harvard is doing something behind the scenes every few seconds, which is why that row reappeared, because indeed, I'm trying to record my network activity. But let's go ahead and do this. Let me clear that one more time and reload the page, and so many rows just flashed across the screen. In fact, in the bottom left-hand corner, you'll see that my browser, unbeknownst to me, made not one, but 67 HTTP requests. That's how many envelopes essentially went back and forth between my browser and harvard.edu a moment ago. Here comes another, and if we just keep this open, it's going to come again and again. Harvard is kind of keeping the page alive. But let me zoom out and scroll back to the very top of this and focus on just the first page I requested, and click on www.harvard.edu, and let me click on headers here. What I'm seeing is diagnostic information, if you will, about what I just did. And you'll see that the URL I requested was indeed this thing here. I used a request method of get. Unbeknownst to me, get is what is used by default when you just type a URL and hit enter. Then the status code that came back, there's that 200. So it turns out that what web servers and browsers have done over the years, thanks to HTTP, is they have standardized what these numeric codes are to indicate success or failure. In the world of programs that you and I have been writing, we typically use 0 to indicate success and maybe 1 or 2 or some other integer to indicate failure. In the context of the web, it's kind of the same idea, but the web uses 200 to indicate success and other numbers to indicate failure or something else happening as well. Well, what else can those status codes represent? Well, let's take a look here. Notice that when I'm in my browser and I go to simply harvard.edu with no HTTPS, no : / no www, no trailing slash, enter, it all just sort of works and brings me to the intended place. Now, why is that? Well, at the lowest level, we can actually see this in our command line interface. Let me go back to my terminal window, which I've still full screened, and let me type this time curl -I, and then simply http : harvard.edu. So I'm going to help the program a little bit and provide it with the protocol, but I'm not going to provide it with the secure version. I'm not even going to mention www. Let's see what comes back. Ideally, it's a 200 OK, because that's what means success. But what I see here is weirdly that harvard.edu has moved permanently. And this time, the status code, coming back from an older version of HTTP, in this case 1.1 instead of 2, apparently has a status code of 301. So it turns out that different types of responses indeed have different numbers associated with them. And 301 means moved permanently, a sort of redirection, if you will. And where is Harvard's new location? Well, if we scroll down among these headers, you'll see that, oh, the server is additionally telling me that the location to which Harvard has moved permanently is https://harvard.edu. OK, so what this seems to indicate is that Harvard server really wants me to stay on the secure version of the website. All right, so let me go ahead and highlight and copy that. Let me go ahead and do curl-i and that URL. So almost the same, except for the HTTPS this time and the trailing slash, and hit enter. But this time too, notice, and this time the server is using a newer version of the protocol. We're back to version 2. It's still telling me 301. It's not berating me by saying move permanently again. But 301 is enough for me, the browser, to know, oh, Harvard's website is now at this location, www.harvard.edu, again using HTTPS. And so, OK, let's do this one more time. Let me go ahead and copy that URL and do curl-i and that full URL. And now we're back to getting a 200 OK. So among the reasons that your browser is able to figure out what you want is because, one, the server might be telling it, no, go here. No, go here. OK, now you're in the right place. And frankly, browsers nowadays, in cooperation with servers that are configured in a certain way, will tolerate you typing in only harvard.edu and just know proactively, no, you don't want that. You want HTTPS and you want the www because the browser, for instance, has seen that response before from the server. But at the end of the day, it's really just these status codes that are enabling us to actually forge these responses. So we've seen a couple now. We've seen 200 for OK. We've seen 301 for move permanently. There's bunches of others as well, including, for instance, this one here. Odds are most everyone here has seen 404 at some point in their lives. I mean, it's sort of in the human vernacular. We all know that 404 means file not found. Like the URL is wrong, the file was deleted, something is missing. That's a little weird that we as humans have been acclimated to a fairly esoteric HTTP status code, but that's all it is. If you visit a web page that simply does not exist, you will get back not 200, not even 301. You'll get back a similar header like this saying 404, file not found. Now, you might see a web page, and it might be a cute web page, or it might be a black and white text-only web page. It depends how the web server has been configured to show you that information. But 404 indeed means file not found. And here's a non-exhaustive list of other status codes. We've seen 200 OK, 301 OK. There's other 300 level status codes that generally refer to redirecting the user from one URL to another. The 400s generally indicate user error, like your fault, my fault. So 401 is unauthorized. 403 is forbidden, like you haven't logged in properly. 404 is not found. 418 is actually an April Fool's joke from years ago. I'm a teapot was sort of a funny joke among engineers. More on that if you Google it if you'd like. 500 range errors means server error. So someone screwed up, maybe not you, but frankly, in a couple weeks' time, when you're writing web-based applications yourself, anytime you see a 500, it is your fault also. So you are both the user and the server in that there case. But long story short, the way these things work are simply underneath the hood via these status codes, which really are being sent virtually inside of envelopes like these. Your browser is generally hiding that detail because normal users don't need to care about this level of detail. But you've always had the power of opening your own browser's developer tools and poking around and seeing these things. And all I'm doing in my black and white window here with curl, which connects me to a URL using a command line interface, is showing you even more in detail what's inside of those envelopes. But it's just another way of viewing the same kind of information. Now, we can actually have a little bit of fun with this, with a smile and a wink to our students at Yale who are perhaps watching this now. It turns out, has anyone ever been to this URL here? safetyschool.org. I'll zoom in here in a new tab. Has anyone applied to safetyschool.org or visited safetyschool.org? Well, we love them equally. But turns out if you go to safetyschool.org, you end up at this here website, which if I zoom back in is apparently https://www.yale.edu. So what is going on there? Well, I could open my developer tools, but let me use my newfound command line skills and do it here. curl-i http://safetyschool.org. Enter, and you'll see that, oh, safetyschool.org has moved permanently to Yale.edu's own website. So this is to a practical joke that has lived on the internet for years. There is someone out there, I don't know who they are, they have been paying an annual fee for years now simply to have this esoteric joke for us computer scientists. There are ones for Harvard as well, in all fairness, but this is one that's perhaps been around the longest. So somewhere there's a Harvard alum who's getting older and older, but is still paying this bill year over year since the web was invented. All right, we're back, and we now focus on HTML, hypertext markup language, which is the language in which web pages are written. It is not a programming language, and as such, we won't need to spend all that much time on it because the basics of HTML are fairly straightforward, even though it has a decently large vocabulary, different features that you'll pick up invariably over time. What HTML does have fundamentally are what are called tags and attributes. These are the basic building blocks of the language, and what the language looks like is this. So here is perhaps the simplest web page that I could come up with, a hello world web page, if you will, and it's just text. It is text that's typically stored in a file, like index.html for short, and in that file would just be these lines of code. And these lines here are going to indicate to the browser what it should do upon receipt of an envelope containing this message. Now, how are we going to go about serving up this content? Well, ultimately, we just need to put this content on an actual web server. Well, it turns out you already have a web server, even though you haven't been using it as such. In other words, when you visit cs50.dev and use VS Code in the cloud, you're obviously using a browser, but you're less obviously using a web server that is serving up a copy of VS Code to you in that browser. But the caveat there is that by default, you've probably been in the habit of typing cs50.dev, enter, and you've probably noticed, if not prior to today, after today, that the full URL ends up being https://cs50.dev/ and then maybe some other stuff after that. But implicit in that URL is one of those port numbers that we saw in TCP, either 80 or 443. Because it's HTTPS, it's actually the latter, 443, which indicates implicitly that there must be a server on cs50.dev that is listening for requests and is serving up that version of VS Code. In fact, we eventually redirect you to GitHub's version of VS Code, aka code spaces, but the idea is the same. And in that URL, you have a web page that's being served up to you, but it's already running on port 443 and perhaps 80. Which is to say, if we want to come up with our own web server, we could like start up our own server, connect it to the internet, give it an IP address, and then communicate with it using port 80 or 443. But it's actually a lot simpler to embrace the reality that any server can have multiple services, be it web or email or video conferencing or the like, or heck, 2 different web servers. And so even though VS Code in the cloud is already running a web server, because that's indeed how it works, there's nothing stopping you and me from inside of VS Code starting a second web server, so long as we choose a different port number, a different TCP port that's not already being used by the server itself. So how are we going to do that? Well, we're going to introduce you to a new command today, called quite appropriately http-server. This is a command that you can run in your terminal window that will start your very own web server by default on port 8080. 8080 isn't that special, but it tends to be a convention. Whenever you want to run a web server on a port other than 80 by default, you would just use 8080 as a go-to. But it could really be any number within a large range. Now, this http server command is going to allow me to serve up some actual content. What might that content be? Well, let me go ahead and do this. Let me go ahead and run code index.html. And let me go ahead and whip up a very simple web page herein. And I'll explain in just a moment what these lines are. But let me go ahead and just kind of transcribe it in this here file. So angle bracket, exclamation point, doc type, HTML, close bracket. Then I had HTML lang equals quote unquote en. Then I had head. Then I had title. And inside of that title, I had hello, comma, title. Below that head, I had open tag body, inside of which I had hello body. So there's a lot of weird stuff going on here if you've never seen this before. But I think I have recreated the file you just saw in slide form a moment ago. What I'm now going to do is try to view this file inside of my browser. But to do that, I need to do this. I'm going to go ahead and run HTTP server, enter, and a whole bunch of stuff is going to appear in my terminal window, some diagnostic output, a URL, and the like. But in particular, I'm going to get this little pop-up that's telling me, oh, my application running on port 8080 is now available. This is just a user-friendly feature of VS Code, specifically CS50's own extension therein, that allows me to click Open in Browser. I immediately get a second tab inside of which I see the contents of my code space at this moment in time. Now notice, to save myself some time today, I've downloaded in advance a source 8 folder, inside of which are a lot of today's examples, if I so need them. And there's a file I literally just created called index.html. What you're seeing here is a directory index of my current folder. So this is a dynamically, automatically generated web page that's simply showing me in a web browser what is inside of my code space. Now, what's my URL? Well, it turns out it's going to be something that ends in github.dev, which is a domain that GitHub itself controls. So that's going to be generated for me automatically. It's not a domain name I had to buy or sign up for. And it's really meant to be temporary because I'm going to use my code space as a development environment to develop web pages. But most important for now is that indeed this server program is running on localhost, which is a nickname for the local computer, no matter what its actual name is, specifically on port 8080. And this is why I'm now seeing my folder instead of VS Code. This tab has port 8080. This tab would appear to have port 443, which is GitHub's own web server running at this domain. Now I'm going to go ahead and click my index.html. And we will see what the simplest web page in the world might look like. And voila, there is my hello body, which is the only thing in this otherwise big white rectangular region, otherwise known as the viewport of my browser. And if I zoom in at the top here, you'll see that my title of my tab is indeed what we saw earlier, hello, comma, title. So long story short, even if you're completely new to developing web pages, clearly we have the ability with this language called HTML to indicate what the title of a page should be in its tab and what the contents of its body should be, as underwhelming and as black and white as all of this might be. Well, let me go back to my sample code here, and let's now actually introduce some building blocks herein. So what is actually going on? The first line of code that I typed, that you see highlighted here, is the page's so-called document type declaration. That's a silly mouthful, but it's really just a standardized line of text that says, hey, browser, here comes a web page written in HTML. Specifically version 5 of HTML, which is what most of the world is now using. Odds are this line of code will change over time, but for now, this is what we have. Below that, things get a little more interesting and a little more symmetric, if you will, and no more exclamation points like you see in this first line. That's a bit of an anomaly. Down here, you'll see what I'll describe as open bracket, HTML, then the space, then lang equals quote unquote en, then close bracket. And by open and close bracket, I mean a less than sign and a greater than sign, respectively, which you can type on your keyboard. What this is doing is the following. This is the beginning of an HTML element, as we might call it. And the tag here for this element is called HTML. So anything immediately after a less than sign is the name of the tag. And the way that browsers work is by relying on these tags to know what to do and where within the confines of the browser. So you can think of this first tag as saying, hey, browser, here comes some HTML. Now, what is that HTML all about? Well, this thing here highlighted, lang, short for language, indicates what human language is presumably going to be used throughout the rest of the page. All of the tags, all of the attributes, for better or for worse, are going to be in English because the language HTML itself was standardized by English-speaking people. You can write web pages with your own content in any human language. In this case, I have opted to write my page, as simple as it is, in English as well. Hello title and hello body. And the en attribute value here, so to speak, is just like a clue to the browser that in case you've got Google Translate or any kind of automatic translation, this is a little hint as to what the human language is to facilitate automatic translation or search engine optimization, SEO, or the like. But that whole thing started the HTML page. Now we have a sequence of other tags. Hey, browser, here comes the head of the page, which metaphorically is like the very top of the page here, aka the tab that we looked at a moment ago. Hey, browser, here comes the title of my page. What's the title? The title is hello, comma, title. Now things are a little weird. The next line of text here is open bracket / title close bracket. And whereas therefore I might call the previous tag the open tag or the start tag, this one here now would be the close tag or the end tag. So there's a symmetry here that effectively is conveying to the browser, hey, browser, that's it for the title. The title is now complete. What comes next? Hey, browser, that's it for the head of the web page. Nothing left in there. What comes next? Hey, browser, here comes the body of the web page, sort of everything else. The big contents of that white rectangular region is the so-called body of the page. Hey, browser, here's the contents of the body. Hey, browser, that's it for the body. Hey, browser, that's it for the HTML itself. Now notice the / indicates the end tag or the close tag, and you don't need to be super verbose. Even though my HTML tag started with a language attribute, lang equals quote unquote en, you don't need to repeat the lang, you don't need to repeat the quotes or the en. It's sort of obvious to the browser that this is closing the previously opened HTML tag. Now, in general, the tags you're seeing should exist in one and only one place. You must use these tags in certain locations. We will soon see bunches of other tags that you can use 0 or more times to structure the actual contents of your own page. So how do we get into that, and what are we ultimately doing? Well, what we really have is, in this HTML code, a textual representation of a tree. One of our now familiar data structures, whereby there's a root of this tree that has some number of children, that might have some number of grandchildren, and so forth. And so depicted here at right is what you might call a document object model, or DOM, D-O-M for short, which is actually what the browser is probably doing in its own memory, or RAM, when it accesses a web page. In other words, if you type in google.com and hit enter, you immediately see the contents of Google's website in your browser. What Google has probably done is sent text that looks kind of like this, but more complicated than this simple example. That text is read top to bottom, left to right by your browser and loaded somehow into memory using malloc or other techniques like that to create bunches of nodes in memory with a lot of pointers that somehow represent this tree structure in the computer's memory so that it actually knows what to display on the screen. So with that said, let me go back here to VS Code, and I'm going to go do a sequence of examples now, and I'm going to go back to the code and then back to my browser to show you exactly what's going on. Recall that at this moment in time, the only two things I have are a source 8 folder, which I came with by default today in advance in case I need to copy paste anything, and index.html, which I just created for the first time. So let me go back to my VS Code tab here, and you'll notice that in my terminal window, there's actually a bunch of logging information, diagnostic information. Long story short, anytime anyone visits a web server with a browser, odds are the server is logging that visit. In fact, this is how companies know. This is how internet service providers know. This is how parental controls know what websites you are visiting, because all of this information is going back and forth between browser and server. Here, because I am running the server via that HTTP server command, I now get access to all of this juicy information, including what the browser is that the user is using, what day and time they visited my page, and so forth. But for the sake of discussion, I'm not going to really care about this diagnostic information. I'm going to hide this for the most part. But notice too under ports now, whereas previously I only had one TCP port in use, 1337, which is CS50 specific. Now notice that VS Code has detected that I'm running something else on port 8080. So you see a second port there, and you might, over time, if you open more and more tabs, see even additional ports as well. That all happened for you automatically. So for now, I'm going to go ahead and hide my terminal window because I don't really care what's going on there, but that's still going to keep HTTP server for me running in the background. Let's go ahead and introduce some new tags. So for instance, let me go ahead and create a new file. Actually, let me retract that. Let me open my terminal window, and instead of showing the log, let me create a second terminal window with the plus icon. So I'm still running the other one with the command, but I still have the ability to run commands now in my here prompt. For instance, I want to run a command, code paragraphs.html. Let's go ahead and create a more interesting web page with actual paragraphs of English or other type of text. To save myself some keystrokes, I'm going to be in the habit today of copying the hello world example as a starting point, perhaps, and then just changing it as needed. For instance, I'm going to change the title of this here page to paragraphs. And then in here, I'm going to type out some paragraphs of text. Now, what are those paragraphs? Well, I wanted to save some time. So in advance, I generated some Latin-like text here so I can copy paste 3 long paragraphs of Latin text, some lorem ipsum text here. Now, it doesn't matter what this means. It's sort of nonsensical words. But this is a web page that is going to have ultimately some paragraphs of text. Not English, but fake Latin. So let's go ahead and open this. Let me go back to my other tab. I do need to reload this tab because I've created a new file that this browser didn't know about before. There it is, paragraphs.html. Let me go ahead and click now, paragraphs.html. And there are my 3 paragraphs. Well, wait a minute. This is just like one big blob of a paragraph instead of the 3 paragraphs that I was promised. Well, why is that? Well, let me go back to my editor here, and you'll see that even if I hide my terminal here, even though I've got these blank lines, clearly the browser is just ignoring me. And this is because HTML is pretty pedantic. Like, it is designed to only do what you tell it to do. And so if you don't tell it explicitly, give me a new paragraph, it's just going to combine adjacent texts, as we've seen already. So how do I do this? It's actually pretty simple. Let me go into my body tag, and let me actually open a paragraph tag, or P for short. Now notice VS Code is trying to be helpful by automatically completing the rest of this thought by giving me both a start tag and an end tag. In this case, that's not really helpful because I already have the text that I want to put inside of this paragraph. So I'm going to go ahead and delete the close tag manually, and I'm going to move over here and close this myself. And just to be stylistically nice, I'm going to go ahead and indent that. Now down here, I'm going to do one more paragraph tag, P for short. I'm going to cut that out, and I'm going to paste this in here. And again, I'm fighting with the auto formatting because it is trying to understand what I intend, even though I'm going back and fixing this now. Let me fix that. Let me go down here. Let me go ahead and fix this now. Indent here, and voila. Now we've got 3 paragraph elements. And to be clear, an HTML element is generally everything between a start tag and an end tag. So I have 3 paragraph elements, P for short. Why is it only P? Well, the designers of the HTML language years ago decided, why write out paragraphs when open bracket P, close bracket suffices? So let's now go back to my other tab. If I now, I see nothing changed, but again, that's because I already received the virtual envelope in my browser that contained the previous version of that page. If I want to get a new copy of paragraphs.html, I need to reload this tab, and now I see the same text, but broken down into 3 separate paragraphs. So this is just to demonstrate the point that if you want something to happen, you really need to tell the browser to do exactly that. Well, let's introduce some other tags too. Let me go back to my editor here. Let me go ahead and open my terminal window, and let's create something called headings.html. Much like a book, much like an academic paper, you might have section headings, like the chapter and the section and the subsection and so forth. We can actually implement this with some HTML too. So let me kind of cut a corner here and copy and paste paragraphs.html into headings.html. Let me hide my terminal window. Let me change the title here just to be headings, to be super explicit as to what's going on. And let me go ahead now and say h1, 1. And down here, let me say h2, 2. And down here, let me say h3, 3. Now, these are 3 new tags, h1, h2, and h3. By definition, h1 is typically big and bold. H2 is typically not quite as big, but still bold. H3 is not quite as big still, but still bold. And these are the default stylizations of these here tags that come with HTML. Let me go back to my other tab. Let me click back. So I now see my new file, headings.html. Let me click on headings.html. And now, even though it's still nonsensical Latin-like text, at least it's starting to look pretty. Looks like a chapter of a book with some sections and subsections and so forth. That's because the browser now understands what it is I want of it. Now, you could simulate this by just literally typing the word 1 in its own paragraph, the word 2 in its own paragraph, the word 3 in its own paragraph, but it wouldn't be bigger and it wouldn't be bolder. And when it comes to the semantics of web pages, it's probably useful to use tags, in this case, like h1, h2, h3, because it kind of indicates the relative importance of the text. Like, this is the beginning of the text, this is maybe some finer detail, and then this is the finest detail. It might actually help search engines, or heck, even AI nowadays, understand that these are different sections in your text. And we'll soon see there's even other tags you can do to be even more helpful to the browser and search engines and AI. Well, how about something else? Let's move away from big blobs of nonsensical text, and let's do something with a chunk of nonsensical lists. Let me go into my terminal window, create a new file called list.html, and let me copy paste my hello code from earlier just to save some steps. And let me go ahead and rename the title to list in this case. And let's just have a list of 3 things: foo, bar, and baz. If you've never heard these words before, they're sort of go-to computer science words when you just want some random placeholders. They mean nothing per se. But foo, bar, and baz are go-to default words like X, Y, and Z for mathematicians. All right, this looks like a nice, pretty list. I've indented it, which looks great. But if I go back to my other tab, hit back, and I click on list.html, I think you probably know where this is going. Just like the paragraphs, we just get one big paragraph of foo, bar, baz. We don't get foo on one line, bar on the next line, baz on the third. Well, why is that? Well, just as before, the browser seems to be ignoring white space beyond single white spaces. In fact, I can try to be really explicit, like, please give me some breaks between these lines. But if I go back to my other tab, click reload, it just canonicalizes multiple spaces into a single space, for better or for worse. So if I really want a list, I need to tell the browser that I want a list. And one way I can do that is as follows. Let me delete that temporarily. And let me do UL for unordered list, which means I'm going to get a bulleted list with little circles next to each word. Let me then use an LI tag for list item and type foo inside of the first. Let me type another LI tag and bar for the next one. And then a third with baz. And again, VS Code is auto-completing, which is why I'm able to type the close tag so quickly. But I've got now foo, bar, and baz inside of LI tags, which in turn are inside of a UL tag. Now, let me go back to my other tab, click reload, and now we have a bulleted list of items, one at a time. Well, what if I want to number this list? Well, I could certainly just go in here and start manually writing 1 and 2 and 3. But you could imagine that getting a little annoying over time, because if you need to reorder the list or add things to it, like, it's just minorly annoying to have to maintain numbers for lists of things. Like, this is what software is good at. This is an easy fix. And you might guess where I'm going with this. If I want to move from an unordered list, which is just bullets by default, to an ordered list, which is numbered, I can change the UL to an OL in both places so that my start tag and end tag still match. I can go back to my other tab, click reload, and what's going to happen by default now is, I get 1 and 2 and 3. And long story short, there are actually techniques whereby you can change this behavior using attributes to not just be these Arabic numerals, but you can use Roman numerals or other symbols that browsers are designed to support. And it all just kind of happens for you, which is great, because if you're writing something like an outline for a paper or the like, you don't really want to have to think about all of those numbers, just like Google Docs and Microsoft Word. Like, the software should figure that out for you. And indeed, HTML can do just that. All right, how about one other here? This time, let me go ahead and cut a corner and open a file I created in advance just to save a few keystrokes. Let me close most of those files for now. Let me go ahead and copy from my source 8 directory a file I brought with me called table.html. And let me open this up in its own tab. And you'll see this file here that demonstrates a table. And indeed, I know that because I have atop this file that I wrote in advance something called a comment. We've seen comments in C with //. We've seen comments in Python with hash symbols. In HTML, a little weirdly, you can write comments with open bracket, exclamation point, dash dash. Then you write your comment, and you finish your thought with another dash dash, close bracket, but no additional exclamation point. Why these keystrokes? Well, the humans who designed this probably figured, who is ever going to type that sequence of keystrokes? Like, that's what we'll use for our comments tag. As an aside, if you ever actually want to write those patterns of characters, there's a way to escape those things, as we've seen in other languages as well. But let's focus on the juicy part here. What's inside the body of this here page? Apparently something called a table. And a table, by that we mean tabular data, like in a spreadsheet or in a database table. TR, I'll tell you, is short for table row. TR. TD, a little less obvious, but it's short for table data. So it's kind of like the cell in that row. And the fact that there are 3 table data elements inside of this one table row element means that there's going to be 3 cells, or really 3 columns from left to right, inside of this row. Below that is going to be another table row, inside of which are 3 more cells, 4, 5, 6, as their contents. Then 7, 8, 9. Then, curiously, an asterisk, a 0, and a pound symbol. So where are we going with this? Well, if you're imagining in your mind's eye a telephone that has buttons and labels, it seems like I've just been laying out rows and columns of numbers you'd see on your cell phone or an old-time landline phone. Well, let's still open this. Let me go back to my other tab, click back. Now you see table.html, and this isn't going to be all that pretty, but it is tabular data. And if I zoom in with Command plus here in my browser, you can see that this is laid out rather like a phone pad. Now, this is not a super compelling use, but you can imagine actual tabular data, maybe data that came from a database, maybe Google, in fact, when they implemented Google Sheets, or Microsoft when they implemented Office 365 in the cloud for Excel, maybe that's how they're laying out all of your data in your browser as it is. Underneath the hood, they are using, of course, HTML, but specifically table tags like this. Now, as an aside, they're probably doing even fancier things than that nowadays, but they certainly could use TR tags, TD tags, and these table tags as well. All right, enough about text. Let me actually go back to VS Code here. Let's close table.html, and let's do something with an image. In fact, let me go ahead and grab a file called maybe bridge.png, which is a portable network graphic version of the bridge with which you're now familiar, that we ran a number of filters on in the past. And this is now in ping format because BMP format, which we used in a previous problem set, tends not to be used on the web or supported necessarily by browsers, but pings are, GIFs are, JPEGs are, and potentially a few other formats as well. So I'm pretty good going with portable network graphic. We're good to go. So let's create a web page that actually includes this image, because at the moment I'm just showing you the image. I'm not actually embedding this image in a web page like Google or other websites would. So let's do this. Let's close that tab. Let's open a new file called image.html. Just to save some keystrokes, let me copy paste my hello world example again, changing the title to image. And in the body of this page, instead of any text, let's actually put an image from Harvard University. Let me go ahead and use open bracket IMG for short. Source equals quote unquote bridge.png. So in this case, we have a couple of new things going on here. We've got a new tag, of course, IMG, which is short for image. Why? It was just faster to type for humans than image, so they called it 3 letters instead of 5. Source is representative of another attribute. We saw an attribute earlier, lang equals en. Well, it turns out that the image tag, if you read its documentation or listen to me now, has an attribute called source, src for short, that allows you to specify the source of an image that you want to display in the page. But somewhat differently here, the image tag that I've written has no close tag, no end tag. I could do this, but frankly, open bracket / image, but frankly, this seems a little unnecessary, if not confusing, and it is technologically unnecessary. It turns out that some tags can be empty in the sense that they don't need a close tag, and an image kind of makes sense, right? Unlike a head of the page, the title of a page, the body of a page that start over here and maybe end down here, an image is either there or it's not. Like you can't start showing the image and eventually stop showing the image. Like it's either there or it's not. So you don't really need an end tag for certain start tags. An image is among the examples. If now I go back to my table here and click back to see my directory index, there is not only my ping, but also my image.html page. And if I click on this, it's not all that different from looking at the image itself, but apparently this is a pretty high resolution photograph that we took. I haven't done anything to resize it. And so what I'm seeing is a web page inside of which is this entire image. So that's OK, but I'm going to need eventually some techniques for shrinking this down. And we'll come back to that in a little bit. CSS, another language, is going to be one of our solutions to that there problem. But of course, things can go wrong. For instance, suppose that I mistyped this and I wrote bridge without the E, and I go back to this page and reload. That's, of course, a typographical error. And I see this broken icon. And you might have seen this on the real web. Sometimes images are broken because it's essentially a 404 happening underneath the hood. And in fact, the image just cannot be found. So if I want to help the user with this for a number of reasons, I can actually do this. Let me add an alt attribute for alternative and say something like Harvard University. In other words, in the event this image can't be displayed, go ahead and at least show the user some explanatory text. Better still, if someone is blind or they are using a screen reader to help them hear what is on a web page that they otherwise can't see, the alt attribute's value can be spoken aloud to someone with a screen reader so they know exactly what the image is that everyone else can see, so they can still appreciate what the contents of this web page are. If I go back to my tab here, in this case, it's still a typographical error, but at least now people with and without screen readers can see what this image is supposed to be. And even if I fix the typographical error and reload the page. If someone can see the image, they now will. But if someone's using screen reader software, which for those unfamiliar is software that looks at a web page and tries to describe in English or some other human language what is on the web page, now we have helped that device be all the more accessible as well. So you might have 0 or 1, or now it seems 2 attributes on a given tag. All right, well, what else can we do in terms of media? Well, there's something else we can do here. And I'll just show you this one and let you play around with it online if you'd like. In my source 8 directory, I've actually got a video file called video.html as well as video.mp4. And if I open the former of those, you'll see a page I wrote in advance that shows another technique about HTML. At the end of the day, we still only have tags and attributes. So like fundamentally, we've not really pushed ourselves too far here. But notice that there's a video tag in HTML that does come with 2 attributes at least, one called controls, one called muted. The controls attribute just means please show the user like a play button and a pause button and maybe some other things. The muted attribute means literally that, mute the audio by default. And that tends to be a good thing because nowadays browsers are pretty defensive against advertisements and annoying advertisements like videos auto-playing on websites. So you can ensure that your video will still auto-play, but without bothering the user. So you can mute the volume at least by default. But what's worth noting for our purposes is that some attributes apparently don't even need values. There's no equal sign. There's no quotes, which in some cases are necessary to specify the language of this page is in English. But some attributes indeed do not need values. And even if they do, you can use, as in Python, single quotes or double quotes, and sometimes no quotes at all. But I would get into the habit still stylistically of using double quotes for consistency as I have. But as for the rest of this, a source tag exists, which you can put inside of the video tag. It itself has, confusingly, a source attribute, SRC for short, as well as a type attribute, which indicates what type of video are you trying to play for the user. So I'll wave my hands at some of that media, but you're welcome to play that page and open it on your own and even unmute it to see what I've otherwise shown. But let's now make the web all the more interactive. Let me close that example. Let me go ahead and open a new file called link.html and start making the hyperlinks with which we're all familiar. Clickable links in web pages, which is what makes the web itself. Let me cut some corners here and copy paste my hello world example into link.html. Let me change the title to link just so we know what's what. And let's actually make a page that has a genuine link to Harvard's, to maybe that image of Harvard called image.html. I could say something like this. Visit Harvard, period. Now this, of course, is just text, so this is not that interesting. But just to make sure we're on the same page, let me click back. Let me go to link.html, and you'll see that I've called it link.html, but there's no link there. I can click Harvard all I want, but nothing actually happens. So let's make it a link. What do I want to link to? Well, I could link to Harvard's website, but I already have a picture of Harvard. Let's try linking to a page relative to this one. Let me go ahead and open a new tag called the anchor tag. A for short. Let me use its attribute called href, which is a little arcane, but it stands for hyperreference, the destination of this link. Let me add some quotes and say image.html, close quote, close tag. And then notice VS Code's trying to be helpful, but sometimes it doesn't know what I intend. So I'm going to delete the end tag, move my cursor over, and paste it at the end and finish my period there, just because I want everything to be balanced. And now, even though this one looks a little more cryptic, this is now the beginning of hyperlinking pages on websites. If I go back to my other tab, click reload, now I see the familiar underlined text, which of course signals in many web pages that this here is a link. If I hover over it, it's going to be a little small, but in the bottom left-hand corner of my browser, which is Chrome, I can actually see that this will lead me to a page called image.html. And indeed, if I click on Harvard for real, I get back to image.html. And the URL in my browser has changed from link.html to image.html. So this is what's known as a relative link, whereby I'm linking from one of my own pages to another of my pages. They're in the same folder, so I don't need to mention any folder names. The server just knows what I want. So that's then a link. But what if I want to link to an actual URL and not just a relative page like Harvard's own website? Well, that I can do too. I can change the value of this href attribute, and I could just do harvard.edu. Unfortunately, this is not going to work. The values of hrefs in a web page, if they're going to be full-fledged URLs, have to be actual URLs, protocol and all in this case. And so I'm going to do https://www.harvard.edu. And heck, I'm going to include the trailing slash even though I don't strictly need it. And technically speaking, I could omit the protocol if I want the same protocol to be used. But in general, I'm going to link to the full-fledged URL of harvard.edu here. I'm going to go over to my image tab. I'm going to kick back to go back to my link tab. I'm going to reload to make sure I get the latest HTML in my browser. And if I hover over this now, super subtle, but in the bottom corner of my browser now, this indeed leads me to harvard.edu. And if I click that, we should see the familiar forests that we saw a little bit ago. And now this is an external link, not a relative link that I've now implemented in this web page. All right, let me click back. And let me reveal one other feature now of those so-called developer tools. Previously, I opened up developer tools when I wanted to play around with HTTP, the protocol that just gets the web pages from browser to server and back. But now it turns out I'm going to use another feature of my developer tools by right-clicking or control-clicking anywhere on my page or going through the main menu. I'm going to click Inspect. And now Inspect makes a little more sense because now I'm literally inspecting the web page itself. Notice at left here is a visualization of the underlying HTML of this web page. And some of it's hidden, but I'm going to click the little triangles to reveal the rest of it. And you will see essentially at left here under the Elements tab in Chrome a list of all of the elements that compose this web page. And again, an element is everything between an open tag and a close tag. So in this case, I am seeing a very pretty printed version of my own source code. And some things are broken out onto different lines just to make clear that here's some text, here's a link, here's some other text, both of which are inside of this body tag. And notice too, as I hover over things, Chrome, just to be helpful, because if I'm a developer, I want some help here, I can see in light blue what I am hovering over in my HTML being mirrored in the actual body of the page. If I hover over the body, I see everything to the body as well. Now, what I can take away from this is the following. This here is my web page, and it's very pretty printed. If I close this tab, I can see my same code in another way. If I right-click or control-click, I can also go to View Page Source. View Page Source is a feature that's been in browsers for years, and you can see the same code, but exactly as it came from the server. I happen to be pretty nitpicky, so it's all nicely indented as well. But this is a static version of the page, whereas the developer tools allows me to actually poke around with things. In fact, let me close this tab. Let me re-click again on Inspect. And watch this. If I want to poke around here, I could actually go into the developer tools and temporarily, without even going back to my terminal window, I can click on or double click on anything in this page, and I can actually change it in real time. Like I can change Harvard to Harvard University and then hit Command Enter. And in this case, I can change the contents of the web page. But curiously, that has not changed anything on the server, because this makes clear the point that once the browser has requested a web page from the server and downloaded that virtual envelope inside of which is the original version of link.html, that's what the browser is going to keep in its memory. You can change your copy of that page all you want, but it doesn't affect the server at all. The browser gets a copy of what's on the server. In fact, we can take this feature out for a spin, seemingly maliciously, but not in a way that has any effect. In fact, let me pull up not just harvard.edu, but specifically the admissions page for Harvard College, and scroll down here, and you'll see this advertisement toward the end, why Harvard? Well, notice that if I want to see the underlying HTML of this page, I can see it in a couple of ways. I can right-click and choose View Page Source, and it's going to look like way more code than we've written to date. This is me scrolling through all of the HTML that composes the admissions website's HTML at Harvard. There's a lot there, but it's going to follow that same pattern of tags and attributes. Or I can kind of pretty print it by going to Inspect, going to the Elements tab, and there, notice, is the exact same content, even though I was scrolling through it super fast, but it shows you everything pretty printed, so you can kind of poke around. More importantly, I can click on any part of the page with my Control key or two fingers and select Inspect. And what's nice is that Chrome, and really any browser, will jump to the specific HTML in the browser's memory that corresponds to that part of the page. The upside of this is I can actually infer, how did Harvard make this web page? How did they structure their HTML? Now, we haven't talked about all of these tags yet, but notice that there's all of these div tags, div, there's a section tag, but there are some familiar ones. Here's an h2. Harvard is using an h2 tag for why Harvard. Here's a ul down below for some kind of unordered list. But notice here I can be a little playful here, and maybe we should nudge people to go to Yale instead. Let me change in the Elements tab, Harvard to Yale, hit Enter, and now I seem to have hacked Harvard's website, and it suddenly says why Yale instead. But of course, this changes nothing on the server because this too is a copy. And the moment I reload Harvard's website, I get a fresh copy of what's actually on the server. So what's the value here? Well, one, pedagogically, it's just a useful mechanism, these developer tools, for understanding and learning how a website is structured if you want to do something similar yourself. As a developer tool, frankly, sometimes it's a lot faster to just mock things up in the developer tools, decide, OK, I like how this looks, and then go over to your actual HTML and make the changes for real. It's a faster way of iterating, and it's also a helpful way of diagnosing certain problems that we might otherwise run into. All right, but there's still a danger here. Speaking of Harvard and speaking of Yale, let me go ahead and close that tab there and return to the HTML of link.html. It turns out that the attacks with which you're familiar in the real world, namely phishing attacks, are all too easily waged via HTML alone. To be phished typically means to receive some kind of spam email that's trying to trick you into clicking on a link that purports to be legitimate, but is really taking you to some adversary, some bad guy's website that's trying to steal your credit card information, your username, your password, or something like that. And those emails in Gmail, in Outlook, and other tools, they themselves are using HTML. Anytime you get an email that's not just black and white text, but has colors and maybe images and formatting, it's using HTML. So HTML is used not only for web pages, not only for mobile apps, but also for emails as well. And here's how easy it is to unfortunately deceive users. Suppose that I still have a link here to Harvard, but I actually changed the actual href to be yale.edu. If I go back to my actual browser here and close my developer tools and click reload, the page still says, like the HTML, visit Harvard, period. And this is super subtle, but if I hover over this link in the bottom corner of my browser now, I'm actually going to be led to yale.edu if I click this link. In fact, if I actually do that, voila, now I'm actually at yale.edu. So not a big deal in this case. I'm just sending one student from one place to another. But you could imagine making a website that looks like a bank's website, that looks like PayPal's website, that looks like something legitimate, such that when I click on a link, no one's really looking in the bottom left-hand corner of their browser all the time. You could all too easily trick a user into visiting a page and maybe filling out a form on a page that they didn't actually intend. And we say this not to empower you to do such things, but the opposite, to detect when such behavior is happening. And frankly, getting into the habit of hovering over links that you're a little suspicious about is probably a good practice. But for today, know just how easily these threats can be waged and why there are so many of these threats to us online. It boils down to these basic fundamentals. Now, all that said, we haven't even done anything dynamically. Every web page we've made thus far has still been very static, like content I have made in advance, and you can reload all you want. It's always going to look the same from the server again and again. But how about we revisit how URLs work, not just to serve up static content, but dynamic content as well. It turns out that besides having folder names and file names at the end of URLs, you can also have a question mark in URLs, and then key value pairs, literally with an equal sign in between them. We've seen key value pairs all over the place, most recently in things like dictionaries, for instance. But in this case here, we have a canonical format for how you can actually provide input from a browser to a server, typically that's typed in via a form. So for instance, let me actually open up a brand new tab here. Let me go to google.com, just the main page that doesn't come with my browser. And I'm going to go ahead and type in something like cats, C-A-T. Now, ignoring the fact that there's a whole lot of autocomplete going on here, let me hit enter. And let me emphasize what my URL. We can be distracted for a moment by the cute cats on the top of the page. But let's then zoom in on the top of the page here, where we'll see a very long URL, most of which, frankly, I don't understand, and probably only Google employees would understand what everything is in this URL. But let me delete most everything except the essence of this URL. And what I've left at the top of my browser is only https://www.google.com/search, which is the path, question mark, Q, equals cats. It turns out, way back in 1999, when Larry and Sergey founded Google and created their very first search page, they had a text box just like this one, but more simple in design. And if you filled out that text box with one or more words and hit enter, you submitted a query to the server for which you want to search, Q for short. And so all that form needs to do when you hit enter is change the URL, it would seem, to take that user input in a standard format. Q equals cats. Something equals something. Something equals something. In fact, if there's multiple such parameters, as these are called, just like in functions, you can separate them with ampersands. But the question mark just means to the server, hey server, here come some key value pairs, otherwise known as HTTP parameters. When I hit enter, the search results are actually going to be exactly the same. Most of the other stuff in the URL is probably for tracking purposes, so Google can keep track of what I'm searching for and what I'm clicking on. But in essence, if we distill the URL to just question mark Q equals cats after search, we have provided user input to this here page. And what's cool about that is the following. Normally, the canonical URL might be as simple as this, or it might actually have two key values in pairs, which indeed can be separated by these here ampersands. I think I can take advantage of this here feature and implement like my own version of Google. Let me do this. That's kind of it for HTML. Like there's bunches of other tags and attributes out there, but those are really for an online tutorial or book or reference or some other source to just pick up what more vocabulary there is. At the end of the day, it's just more tags and more attributes following this shared structure. So for now, I want to make things more dynamic, leveraging my knowledge of just that. Let me go back into my VS Code. Let me create my own page called search.html, enter. Let me save a few keystrokes by copying and pasting my hello world code and changing the title to search. Let me get rid of the body here. And let me begin to create my very own form using literally a form tag, F-O-R-M, space, and then here I'm going to close the tag immediately. Inside of this form element now, let me go ahead and create an input whose name equals Q. And inside of this form element, let me additionally add an input whose type equals submit. And we'll see what this gets us first. Let me go back to my other tab, click back to see my directory listing of files, click on search.html, and this is super simple. But I seem to have the beginnings of an interactive web form, a big text box and a submit button by default that seems to be a form. Unfortunately, if I type in anything to this, cats, and then click submit, nothing actually happens. But if I go to my own URL here at the top, notice that I'm still on search.html, but question mark Q equals cats was automatically added for me by the browser as soon as I click submit. So let me go back and add a little more detail in my editable file. Let me specifically specify that the type of this text box is text, but that it turns out is the default. So I'm actually going to enhance that and make this a search box specifically. Let me go back to my browser and reload. And this is subtle, but if I now type in cats, notice that I get this little X here, which is just a user-friendly feature, which means now I can click on the X to clear that box. That is simply because I changed the type of this box from generic text to a search box, for which that feature is useful. I don't really like the idea of submit. I'd kind of like my button to say something about Google. So let me go back to my submit tag here and change the value of that input to be quote unquote Google search. Then let me go back to the page, reload, and now things are getting a little more interesting whereby I have a Google search button. It still doesn't do anything. But let me be more specific. When I submit this form, I want the method to be used, the verb to be quote unquote get. Somewhat confusingly, the convention is to use lowercase here, even though inside of the envelope I've demonstrated with curl that it tends to be capitalized in the actual HTTP protocol. But so be it. But get is actually the default, so I don't strictly need that. But what I do want to add here is an action. What action do I want this form to take when submitted? Well, I don't have a backend. I don't have a database. I have not searched the web ever with this here code space, but Google has. So let me use Google's backend, their servers and database, to search for whatever Q is. Let me change the action value here to be https://www.google.com/search. So just the beginning of that URL without the question mark. Now let me go back to my search tab, reload, and now nothing visually seems to have happened. But if I type in cats now and click on this new and improved Google search button, watch what happens not only to my URL, but the contents of the page. I have just searched from my own web page for cats on google.com. In other words, by nature of how HTML forms work, specifically using the get method and the action of Google's own URL, my browser knows how to assemble all of those ingredients into a brand new URL that contains as the value of Q whatever I typed into that box. And heck, I can do this manually now, even though no one searches like this. I could just search for Q equals dogs, and now I get some adorable dogs as my search results here. But that's just because I now understand what these URLs are doing for me and how they are structured. If I zoom out and I go back to search.html, I can actually make some improvements here to that same form. You might have noticed that when I typed cats the second time, I actually saw it auto-completing as cats. There was a little popover there. If I don't want any autocomplete, there's an attribute for that. Autocomplete equals quote unquote off. This will now disable the browser from remembering things that I've searched for before. I can also do this. Notice if I go back here to my search page and click reload, notice that with no hands on the keyboard, the box is there, the button is there, but my cursor isn't. I have to manually focus my cursor on that box, and then it gets highlighted in blue and I see the blinking cursor. That's not the best user experience, or UX, so to speak. Why you're going to make the user move their cursor and put the cursor where you want it to be anyway. So I can fix that. Let me go back to this same search box and let me add autofocus. And I don't actually need to give it a value, but if I now go back to the page and reload, watch, even without clicking on that text box, it's already highlighted and blinking because I've given focus, so to speak, to that there text box. Now, what is this text box? It's just a big white box. Well, if you read the documentation for, or listen to what I'm here saying about the input tag, you can also have a placeholder attribute that can contain any text you want, like query, for instance, quote unquote. If I now go back to this page, reload once more, now you see in gray text inside of the box sort of explanatory instructions as to what I'm looking for. And as soon as I start typing CATS, query, goes away. So that too is a feature you've probably seen in browsers that's just the result of someone having used the right HTML tags and attributes. Now, I've been a little deliberate here. I have alphabetized all of my attributes, if only because it helps me personally skim things from left to right and know if I've missed something that I intended. But strictly speaking, there's no official ordering to any of these attributes. You can put them left to right, right to left. They don't need to be alphabetically sorted. But stylistically, this is indeed what I myself tend to do here. Let's take a look at one more use of forms that will allow us to introduce another feature that's present not only in HTML, but in other programming languages as well, including, in fact, Python. So let me go ahead and create a new file here called register.html. And let's just imagine that we're trying to create a web page via which someone can register for something, a website, a sport, or anything else. And what I'm going to do in register.html is save a few keystrokes and copy my search code into register.html, and I'm going to change the title to register, and I'm going to get rid of the form as a starting point here. Let me close my terminal, and inside of this form, let's just create the beginnings of a registration form. But unlike the Google example, I'm not going to bother trying to submit this anywhere. That'll be a goal for another time. But let me go ahead and in this form create an input. For which autocomplete is off, like before, for which the field is auto-focused. And you should only have one autofocus field, otherwise the cursor doesn't know where to go. Let me specify that I want this input to be someone's email address, because after all, I want this to be a registration page. So the placeholder text I'm going to be using is email, so they know what to type. And then the type of this field, for now, is just going to be text. And then I'm going to go ahead and have a submit button. But it turns out you can have different types of buttons. And one other way to express a submit button is literally with an HTML element called button, for which the label here will be register. So long story short, there's different ways to implement buttons. Here is now a second way. Let me now go back to my other tabs. Let's close the tats. Let's hit back to get to my directory index. And let's now click on register.html. So very similar in spirit to my search form, but now I'm clearly asking for an email with a registration button. However, I could try to register with anything here. In fact, if I'm not paying attention, maybe I'll just type my name like I always do in these examples and click register. And even though nothing technically happened, notice my URL did change. So the form was submitted because question mark email equals David is appearing there. But that was not an email address. And it would be nice if the browser says, no, that's not an email address. You cannot submit that form yet. But if this is just a text box, it's going to tolerate any kind of text. But as you might know from Microsoft Office and Google Forms, you can certainly validate forms in those kinds of software. Certainly, we could do so in HTML. Well, we can in a couple of ways. Let me go back to my HTML, and let me change the type of this input to be not text, not search, but email. And it turns out that this is one of the officially supported types of inputs nowadays, where the browser will now know that, OK, before I can let the human submit this form, I better check that they're typed in an email. So let me reload this page. Let me again foolishly try to type in just my name, not my email, and click register. And now notice I'm getting admonished by the browser. This is a default pop-up that's saying, please include an @ in the email address. David is missing an @. So obviously, I've not typed an email address. So let me fix this. mailin@harvard.edu. Now the error has gone away. I can click register. And even though nothing useful happens, again, the URL changed, indicating that I did submit the form, just to know we're useful. All right, so that's all fine and good. But it turns out that email is one of the relatively few types of fields that you can check for, in addition to search and text more generally, and a few others as well. But it turns out that browsers nowadays, in the context of HTML, support what are called regular expressions to help solve this problem. A regular expression is a pattern, otherwise known as a regex for short, that allows you to validate input from users and make sure that that input matches some pattern. And this is a bit of a mouthful how you can do these. There's a whole bunch of documentation online, not only at this URL, but in Python's own documentation and in other locations as well. But just wanted to give you a taste of the possibilities, because these are really everywhere in high-level programming nowadays, as well as in this context of HTML. Here is the symbology of regular expressions. We're not in a language. It's just a way of representing patterns, if you will. If you have a dot in a string of text that's a regular expression, that just means any character. It's like a wild card. Any one character can be there. A star actually means 0 or more times. So you can say, give me a character 0 or more times. So there's either nothing there, or there's 1, or there's 2, or there's more. You can use a plus, which means give me 1 or more characters. So not 0, but 1 or more. You can use a question mark, which means 0 or 1 character, but that's it. You can use curly braces, unrelated to Python, and say, I want this many occurrences of a character. And you can have a range inside of curly braces. Give me minimally this many characters, maximally this one. And you can do other things too. In square brackets, you can say, give me any one of these digits, 0 through 9 in this case, but you could type anything in there that you want. You could say 0-9 to specify a whole range without having to type them all out. You can type \D to indicate any digit, so you don't have to type any of that out. Or you can do the opposite, \D, which means anything except a digit. So long story short, and I'm very much waving my hands at some of the details here, there's this whole symbology that humans have come up with in different languages via which you can represent patterns. So this is all to say that I could come up with my own pattern for an email address, even though it's not going to be as good as the browser's own. Let me go back to VS Code here. Instead of saying email type equals email, let me go back to type equals text. Or heck, I can go to the default and get rid of this altogether. But I'm going to use one other attribute we haven't yet seen, which is literally pattern equals quote unquote. Inside of this pattern's value, I can use a regular expression, a pattern that represents what kinds of values I want to accept. Now, I'm going to keep this simple and therefore not very good. But remember that dot means any character. Plus means 1 or more of any character. An @ means literally an @. Another dot means any character. Another plus means 1 or more of any character. Then \edu. What's going on here? Well, we haven't seen this yet. But curiously, if I want to literally have a period in the user's input, well, I can't use dot because that means any character. It was a wild card. So just like in C, just like in Python, I have to escape certain characters. So in regular expressions, if I do \dot, that means give me a literal dot in the user's input, an actual period. And then edu means make sure that the user's email address, in this case, ends with .edu. Now, this is a bit of a simplification because it is not the case in email addresses that you can allow for any 1 or more characters, then an @, and then any 1 or more characters, and then .edu. it's actually more formally defined than that. So this is a very quick and dirty regular expression for an email address. However, if I now go back to my register page and reload, and I again try to type in David and not an invalid email address, that pattern will be checked, and the browser will prevent the form from submitting at all. So I can express different patterns of things. Now, for email, that's not the best thing, because in fact, if I actually look at the official definition of an email address's regular expression, according to browsers, it's actually this crazy long sequence of text using the symbols I showed you as well as some others. But this just speaks to how complicated the definition of an email address's pattern is. So using type equals quote unquote email, definitely the better bet. But let me do something a little more reasonable. If I go back to VS Code here, and let's suppose that we want to ask the user not for an email address, but their phone number. So let me change the placeholder to be phone, for instance, and then let me change the pattern to be that of a US phone number. So here I could do this in a bunch of ways, but I'm going to use \d, which means any digit, and then curly braces 3 times. Then a hyphen, then a \d, curly braces 3, then a hyphen, then \d, curly braces 4. And this here represents a standard format for a US-based phone number, 3 digits, dash 3 digits, dash 4 digits. So this is how I can now ensure that the human types in not an email address, and definitely not their name, but a phone number that at least follows a certain pattern. Maybe not very user-friendly, because do you really want to require the user to type in dashes? Wouldn't it be nice if they can skip those? Maybe they want to use parentheses. So there's better ways, arguably, still to do this. The point here, though, is that web pages and other programming languages more broadly do support these things called regular expressions, which are wonderfully useful in the real world. But there is a danger here. Suppose that even though this catches invalid phone numbers now, register, it's telling me to match the requested format. Unfortunately, as great as all these features are, these patterns are that I just introduced, you as web developers now should never trust users' input. Why? The only thing stopping the user from typing in invalid data, like their name instead of their email, or their name instead of a phone number, or something else invalid, is the code that they've downloaded to their browser. But recall that even though when they view page source, they see exactly what came from your website, they can open their own browser's developer tools via inspect here. They can go to those elements and, for instance, expand the form by clicking this triangle. And if they don't like the pattern you're imposing on them, well, let me just go ahead in there, delete that, hit enter. OK, watch what happens now. I have modified the in-memory version of the web page. I can click register now all I want. And I have just submitted DAVID instead of a phone number. So this is to say, unfortunately, that this week alone, we do not yet have enough skills, enough knowledge to correctly validate user input. We can make the experience more user-friendly. We can tell them right away in the browser, you're doing something wrong. Please don't submit this form yet. But we're also going to need, before long, a server-side mechanism for defending against that kind of attack too. So through phishing, and in this case through modification of the actual DOM in memory, we've seen all too readily how adversaries can try to infiltrate our sites in some way. Now, in addition to the developer tools that come with your own browser, it's worth noting that there is at least one official source via which you can validate your actual HTML. That is to say, make sure that it is well formed and that it actually adheres to the HTML spec. At validator.w3.org is a web-based tool that you can use to copy paste your HTML, even paste the URLs of web pages into. And this is actually a tool that will provide you with some feedback as to whether or not you've made syntactic errors with your actual code. All right, with that said, let's go ahead and take a 5-minute break. And when we come back, we'll introduce stylization of these pages, namely through CSS. All right, we are back, and it's time now to start stylizing these web pages so that they're not just these boring black and white pages that have structure to them, but really no style. And so for this, what we're going to do is introduce another language called CSS, or Cascading Style Sheets, which is another language, but not a programming language, via which you can specify how certain tags should be appearing on the screen. For instance, we've already seen tags like H1, H2, H3, and I described those as big and bold, and not quite as big and bold, and not quite quite as big and bold. But what do we mean by bold and big? It would be nice if we could actually use font sizes or pixel sizes. It would be nice if we could introduce colors and other aesthetics. And indeed, CSS allows you to adorn the structure of your page with the last mile of detail, so to speak. The colors, the sizing, the spacing, the positioning, and so much more. Now, in order to do this, we're going to need to introduce one other term of art, namely properties. And frankly, at this point, we're just coming up with different words for the same ideas in all of these various languages. But properties are sets of, not surprisingly, key value pairs. A property allows you to specify the color of something is this value, or the margin for this something is this value, or the height of something is this value. So properties is just the term of art used in the CSS world to describe key value pairs, just like attributes is the word used in the world of HTML to describe their key value pairs. Same idea for as far back as the dictionaries with which we introduced this here topic. Now, where can you go about using properties and how can you go about using them? Well, it turns out there's going to be different ways of applying properties to elements inside of a web page. And you're going to have to specify as the developer how to select those there elements. And with the wave of a hand, let me describe there as being type selectors, class selectors, ID selectors, and attribute selectors, some of which we will see over time. And all this means is that we're going to use slightly different syntax when we want to refer to different parts of a web page. To do that, though, we're going to need to tell the browser that we want to include some CSS in our page. So here again is that sample HTML that represents really the simplest canonical web page that we can create. This one's just saying hello title and hello body. And if we make room in the head now, it turns out that there can be more than just a title inside of the head of a web page. In particular, you can have a tag called style, which is wonderfully named because inside of that tag, you can put some of those CSS properties, key value pairs, targeting specific elements inside of a web page. Alternatively, we're going to see that instead of using a style tag, you can actually use another tag up here, namely a link tag, which unfortunately is poorly named insofar as it doesn't refer to a hyperlink in the way that the anchor tag and the href attribute does that we described earlier. This one allows you to link in the contents of a .css file, which contains all of those same properties, the key value pairs, but instead of typing them out in your actual web page, you can actually put them in a separate file and include them more readily. But it turns out there's yet another way to stylize web pages, and that's with style attributes. And we'll begin our story there, if only because it's the simplest way to begin. But then, as we often do, we'll try to improve the design thereof. So let me go back to VS Code here. Let me create a new file called home.html and pretend like we're creating a home page for someone, like John Harvard here on campus. Let me go ahead and save a few keystrokes, as often, by copying and pasting my hello world code into home.html. I'll change the title of the page. I'll get rid of hello body. And I'll hide my terminal window so we can now build a home page for John Harvard. Let me imagine this home page as having like three big sections, like a sort of header for the page with John's name, maybe a middle of the page that just welcomes people to his web page, and then a footer with like copyright information or things like that. Pretty common format for a web page, sort of something up here, something down here, something down here. We just need a generic structure with which to play with some HTML and then some CSS. So let me do this. Let me create a paragraph tag at the top of the page that just has John Harvard's name. Let me create a second paragraph below that that says, welcome to my home page, exclamation point. And then below that, let me have a footer of sorts that's just copyright John Harvard in this way. Now, let's go about improving this in a few ways. Well, one, this is a very quick and dirty copyright symbol. It turns out, as an aside, that there's other ways to express characters in HTML, one of which is through what are called HTML entities. Because it turns out, for some symbols that aren't easily typed on your keyboard, you can actually use some special syntax. And I'm going to use this, ampersand, pound symbol, 169, semicolon. And here, VS Code is actually highlighting it, colorizing it so I can see what's going on differently. This is an HTML entity using code number 169, which if you look it up in a book or a manual online, you'll see that this means an actual copyright symbol. So a little C with a circle around it. So useful and commonly used here in the US. Not as easy to type on the keyboard. You could alternatively go Google it, highlight, copy it elsewhere, and paste it in using Unicode. But HTML entities are commonly used still to represent certain symbols like these. Now, let's look at what this web page resembles. Let me go back to VS Code in my directory index. Let me click on home.html. And here we have John Harvard's web page. But notice that there are indeed 3 paragraphs of text, although it's not really appropriate to call these paragraphs because they're really just different parts of the page or divisions of the page. So we'll come back to that. But all of the font sizes are the same. Like there's no making John Harvard big and bold here. I don't really need to see the copyright as big as it is. So you might want to start stylizing content like this. But we have, with HTML alone, structured this web page. So how can I add some style? Well, first, I'm going to introduce a style attribute before then taking it away. I'm going to go to my paragraphs start tag here. I'm going to add a style attribute. And I'm going to change, for instance, the font size here. So font-size, large, semicolon, close quotes. Then on this tag here, I'm going to add another style attribute equals quote unquote font-size medium, semicolon, close quotes. And then lastly, just to keep this going, style equals quote unquote font size, small, semicolon, close quote. Now, strictly speaking, I don't need the semicolons in this particular case. I'm doing it just for uniformity, as we'll soon see. But they're kind of back, just as they were kind of back when we introduced SQL and the end of those statements. But here now, I seem to have added some attributes, the style attribute, to each of these tags that's stylizing the aesthetics of this here page. So the structure is the same, but now the aesthetics are different. In fact, let me go back to my other tab. Let me reload the page, and I should see now these new styles. And indeed, it's a little subtle, but the top line is bigger, the middle line is medium, and the bottom line is indeed smaller. Well, it'd be nice to kind of center everything. So what else can we do with this page? Well, let me go back to VS Code here, and let me, after the semicolon, do something like this. Text-align, center, semicolon. And just to save some time, let me go ahead and highlight everything I just added and paste it inside of those same quotes. So now notice I have more properties. And indeed, that's what we're looking at here. This key, font size, has a value of large. The whole thing, therefore, is a property. And I've used it in 3 different ways with 3 different values, large, medium, and small. This is another property over here, text-align, whose value is center. And I'm using that again and again and again, separating them both, again, by semicolons. Let me go back to my page here. And you might imagine, as soon as I click reload, now everything is nicely centered. So I'm taking some baby steps toward improving the aesthetics of this page, but I dare say I haven't really done this in the best way. Let's chip away at this further. So paragraph tags are fine, but semantically they're really meant to describe paragraphs. And I'm hard pressed to say that John Harvard is a paragraph and copyright is a paragraph. But these are different regions of or areas of my page. So I think what I'd like to do here is just be semantically a little more appropriate. So I'm going to change my p tag to be a little more generically div tags, which stands for division, which is kind of a generic rectangular region of the page, which in some sense is adding less information, but we're going to improve upon this further. This is a very common way to structure pages. In fact, when we glimpsed Harvard's HTML earlier, there were lots of divs in the page because someone who designed that page was kind of laying things out in rectangular regions. And even though there's no visible rectangles, that's kind of what's going on here. It's one rectangular region on top of another. 3 of them in total. But I don't think this is the best design still. Why? Well, let me go back to VS Code here. And even if you're brand new to CSS, let alone HTML as well, you might have noticed that I kind of copied and pasted, and that generally has not been a good practice. It suggests that I'm just doing something redundantly. But what if I did this? What if I factored out that redundancy, that commonality, the text-align center as follows? Let me go ahead and delete it here. Let me delete it here. And let me delete it here. And let me propose that all 3 of these divs actually have a common parent from which they descend, so to speak, namely the body tag. So technically, I could go up here and do a style attribute on the body tag equals quote unquote, and then put text-align, center, semicolon. And the idea of, again, the document object model with CSS is that that text alignment, centering it, will cascade down to the child elements, which are div, 3 of them in this case, so that all of them are still centered. Let me go back to my other tab here and reload. And even though nothing has changed visually, underneath the hood, I have factored out that commonality and applied text-align center to all 3 of those same elements. Now, technically, there's other ways to do this. If I didn't want to stylize the whole body, especially if this is a bigger page that has other elements inside of it, I could actually introduce a parent of my own. It is perfectly reasonable to create a parent div, which after all is just sort of a generic container there. Let me close it all the way at the bottom here and indent it accordingly. And then let me go ahead and indent all of these 3 divs inside of that new div to make the point that if I don't want to apply a style to an entire body of the page, that's fine. I can similarly just do text align center right here, and that too would achieve the same result. And indeed, in Harvard's page, we might have noticed there were lots of divs, not only side by side, but nested inside of each other. Perhaps, it would seem, for similar reasons as well. Now, strictly speaking, I don't have to do it this way. Let me go back to the body approach just to keep it simple. But let me propose that as useful as these divs are, as these containers, whereby each of them describes a different region of the page, I could probably help the internet. I could help search engines. I could help AI. I could help screen readers, for accessibility's sake, understand a bit more about what I mean for each of these divisions of the page to be. So instead of just generically saying div, what I'm actually going to do instead is use 3 semantic tags. And by semantic tags, I just mean HTML tags that are not as generic as div or paragraph, or P for short. I'm going to specify that John Harvard is actually in the header of this page, and I'm going to close that tag accordingly. That welcome to my home page is in the main part of the page, and I'm going to close that accordingly. And the footer is actually in a tag called footer itself, and I'll close that one as well. Now, these are not tags I'm just making up. These are officially in the HTML specification, but they mean exactly what they say. The header for the page is probably useful. It's kind of informational, where you are, whose web page this is. But the main part of the page is generally the juicy part that has actual information that isn't just logos and headings like that. The footer, though, typically tends to be less important. It's got useful stuff, but it's probably not as important as the header and or the main part of the page. So these tags capture those semantics. And the upside is when Google or Bing show you sample search results, or when ChatGPT or some future technology is learning about what this page is saying, it could logically give a little more weight to the header and the main part and less weight to the footer. So you don't see excerpts from the footer, which might not generally be nearly as useful. But what else can we do now that we've introduced these tags? Let's actually take a step toward improving the design of this page too. Generally speaking, it's not the best practice to combine the structure of your page with the aesthetics thereof. In other words, it's not the best idea to combine HTML with CSS all in the same place. Because when I glance at this page, it would be nice if my HTML really did just structure the page. And then somewhere else, maybe in a different file altogether, all of the aesthetics are. Why? Because this way, maybe, I could use different CSS properties for night mode, for dark mode, and for light mode, so that depending on the time of day, the colors of the website might be a little bit different. I could maybe use different style sheets for different devices or different types of browsers or the like. So it'd be nice to kind of factor out the stylization from the web page itself. That said, this is sort of a swinging pendulum in industry. There are technologies that actually do combine CSS with HTML, the argument being that the closer they are, the easier it is to maintain the code and understand what is affecting what. So you'll find arguments in both directions when it comes to the separation of HTML and CSS. But let's take a step towards separating them, at least for our desktop and laptop-based purposes here. Let me do this. I'm going to go ahead and delete all of these style attributes, which is unfortunately going to ruin the aesthetics of the site and make it very generic as before. However, I'm going to reintroduce those properties in a different place. As I proposed earlier, we can make room in the head for not just the title, but a proper style tag. So not an attribute, but a tag. And inside of that style element, what I'm going to put is a few different properties. But the way I'm going to do this is by selecting parts of the web page that I want these properties to apply to. So when I said earlier there's these different selectors in the world of CSS, this is a fancy way of saying there's different syntax you can use to apply automatically certain properties to certain tags or certain types of tags. So let me go back to VS Code here. And what I'm going to do inside of my style element is this. I'm going to specify that any tag called body, which happens to be one and only one, should have all of its text align in the center, semicolon. Unfortunately, curly braces are back when using CSS in this way, not unlike C. But again, we're not programming. We're really just defining key value pairs. Any tag called header, I want to have some slightly different properties. Font, size, colon, large. Any tag that's called main, I want to have font, size, colon, medium. And then any tag that's called footer, I want to have font, size, colon, small. Now, even though this is taking up way more lines of code, it is a step toward keeping my styles separate from the content of the page. And eventually, if you are on the same page as me here, where this might be leading, we can probably copy and paste all of those styles into a separate file. Then two people can work on the same website at once. One person can do structure, one person can do style. We can do the whole light mode, dark mode thing by having different files for different times of day. Feels like a design opportunity. And all we've done, though, is select tags by way of their names here in this particular case. If I, again, go back to my other tab and reload the page, it's actually not going to look any different. But underneath the hood, it's indeed been structured and styled slightly differently. And here's where we have an opportunity to actually reintroduce those developer tools for yet another reason. Let me right-click or control-click on the page. Let me click Inspect. And as before, you can see all of your HTML at left under Elements. But notice at right, all this time, even though I didn't mention it before, you can also see styles for things as well. So for instance, if I click on the body, watch what happens at right. I will then see a summary from my browser of all of the CSS properties that are being applied to the body of the page. One of them is apparently text-align center. And then there's two others, even though I didn't type these out, display colon block, margin colon 8 pixels. And that's the user agent style sheet. Long story short, there are certain default properties that browsers have, be it Chrome or Edge or Safari or Firefox or the like. And what I'm seeing in italics there for the body are some of the default stylizations. And this is why, therefore, some browsers will render the exact same HTML slightly differently unless you try to standardize it somehow with your own CSS. But what's nice about Chrome's developer tools and any of these browsers is here too. Instead of going back and forth between VS Code and my browser tab and reloading each time I want to see a change, I can change things in real time, not permanently, but in the browser's memory. So if I'm just curious and I want to see what this text would look like when aligned to the left, I can type in left and notice it immediately jumps there. If I delete that altogether, notice that Chrome actually shows me a drop-down menu a la autocomplete of all of the possible valid values for the CSS property. So it's a great learning technique too. I don't have to constantly look things up or watch a video online. I can let the browser tell me what are the possible values if I'm learning or I just forget what I can possibly type there. I can go ahead and undo that, go back to having things centered, but I can actually play around a bit further here. Suppose I want to change the font sizes. Well, let me go down to header here. And notice what we meant was font size large for header. Well, honestly, reasonable people are going to disagree what small, medium, and large mean, certainly across Google and Microsoft and Apple and other companies. So what does large actually mean? Well, I could be more specific. If I really want this to mean something, I can say something like 18 point. Which with you might be familiar in the desktop publishing world. I can change this to maybe 24 point to make it even bigger. Or I can even deal in pixels. I can say something like 36px for pixels. And I can get really crazy, like 360. And you see that now it doesn't even fit on the screen. But look how nice it looks because it's being dynamically sized. So I can just kind of play around with these various styles in the inspector itself. So in short, within Google's developer tools, and again, almost every browser has this nowadays, the network tab showed us the underlying HTTP stuff. The elements tab shows us the underlying HTML. And now the styles tab shows us the underlying CSS. And there's so much more, but so wonderfully useful when trying to modify or learn this here stuff. Let me go back now to VS Code, and let me propose to introduce another way of selecting elements. Previously, I mentioned there was this whole list, and what we've just done is select things by way of their type. The type of the tag was body, or header, or main, or footer. But there's these things called classes in CSS2. It's not really the same thing as classes in Python or Java or other languages if you're familiar. But classes in CSS are our own keywords that we can invent and associate our own properties with those keywords. So for instance, if I wanted to reuse styles like text-align center and font size large and font size medium and small, I don't have to associate them with specific tags. I can create my own nicknames for these, if you will. Let me say that anytime I want to center something, no matter what tag it is, I'm going to use a class called centered. Anytime I want to make something large, I'm going to use a class called large. Anytime medium, I'm going to make a class called medium. And anytime small, I'm going to make a class called small. Now, why the dots? The humans who invented CSS needed to come up with some way to distinguish the types of tags or the names of tags from classes. And so you simply use a dot to indicate, hey, browser, here comes a class whose name I'm making up on my own. So anything with a dot represents the start of a class name. How do I use these? Well, let me scroll down to the bottom of the page. And now there's no association yet with any of those class names with this HTML. But what I can introduce now is a class attribute where I can specify, OK, I want John Harvard to be large. And I want the main part of my page to be medium. And I want the footer of my page to be small. And by the way, I want all of this to be centered. So you can create these reusable words, and you can invent the words subject to a few constraints on what characters you can use. But now you have a set of classes, so to speak, that you can use on these tags and maybe bunches of others. They're not that useful at the moment because this web page is so darn simplistic. But you could certainly imagine in Harvard's web page, and Yale's web page, and Google's web page, where they have so many darn tags, might be very useful to use these classes and reuse them so you don't have to copy and paste any of that text as we saw before. And in fact, let's take this one step further. It's a little silly that I keep scrolling up and down. Let's just move all of this CSS to its own file. So let me highlight that and cut it. Let me get rid of my style tags altogether. Let me create from my terminal window a file called styles.css, though I could call it anything I want. Let me paste those lines in there. And VS Code nicely left aligned everything for me. That's it, out of sight, out of mind. Let me close that file. And then inside of the head of this page, instead of a style tag, let me do in link href equals styles.css. And the rel tag for the relationship here is that of style sheet. It's generally the only one you'll use. And this is the kind of thing you might have to look up or copy paste. But href refers to the file that you want to link in, essentially copy paste, but automatically, like an include in C or an import in Python. And the relationship of that file to this one is that of what's called a style sheet, a sheet or page of properties. So let's now perhaps use these techniques to make things that are a little prettier now and a little more visually interesting. Let me go ahead and do this. Let me close out this home page here. Let me go ahead and open up our old file called link.html, which previously looked like this when we left it at Yale. Let's actually undo that phishing attack and change it back to harvard.edu for consistency with before. And let's try to bring this link to life in a slightly different, more colorful way. If I open this page, recall, we did see the link. If I close my developer tools, go back to link.html, notice it was underlined by default, which was great because it made very visually clear that it is a link and not just text. And it was purple, which is the default color in most browsers to indicate, yes, it's a link, but it's one you've already visited. So purple means you've visited it before, and blue typically means it's a link, but you have not visited it before. So that's a default. But suppose I want to override that and make things more crimson or red in nature. Well, let me go back to VS Code here. And in VS Code, let me go ahead and, just for the sake of discussion, let me take one step backward just because it's easier and more efficient during class to reintroduce our style tag. But if you're convinced you could and probably should move this stuff to a separate file, that's indeed the best practice. But I'm going to keep it simple in the same file. Let's go ahead and start to stylize this anchor tag as follows. My anchor tag, abbreviated A, is going to have the following property associated with it. A color of, how about red, semicolon. And now let me go back to the tag here, reload the page, and indeed, it's now red and underlined here. If you want to get rid of the underlying, you can. I could additionally, inside of these curly braces, say text decoration, which is another property we haven't yet seen, whose value is now going to be none. If I go back to my browser tab, reload the page, it's still red, but not underlined. And that's fine, and that's pretty common nowadays. But Here, too, for accessibility's sake, you should be mindful of the fact that depending on the quality of someone's vision, they might not be able to distinguish red from black or red from some other color. So in terms of accessibility, you should make sure that if you're removing telltale signs of links like underlines, make sure there's sufficient contrast between the colors that you're indeed using. So in fact, let me go ahead and leave that alone for now. But let me propose that I'd like to at least show when a user on a laptop or desktop hovers over the link, let me at least underline it then. This is less useful on mobile because on mobile you don't really hover as much as you do tap or not tap. But just so you've seen how in CSS this is done, I can do this too. I can have a selector that says a:hover, which is a special keyword that the browser knows about, which means when I'm hovering over with my cursor an anchor tag, change the text decoration temporarily to actually being underlined. And if I go back to my browser tab, reload, notice that I get now some interactive behavior. Anytime I hover, you can see the line appearing. For better or for worse, this is how you can implement a bit more dynamism then with your here content. And the fact that it's an anchor tag means that it's going to apply to any of the anchors, any of the links in this here page. If I don't want that to be the case, let me propose this. Let me propose that instead of doing this, I want to define some properties as follows. Let's go ahead and undo this. And in this page, let's suppose that we have a visit to Harvard or a visit to href equals https://www.yale.edu, close bracket, Yale. So the page is a little longer now, but the sentence now reads visit Harvard or Yale with two different links. How can I now stylize these a bit differently? Well, let me go ahead and do this. Inside of my style attribute, let me specify that I want the Harvard link to be red. How do I do that? I'm actually not sure I can just yet. But what if I do this? If I know I want to stylize this tag, let me actually give it a unique identifier. There's different ways to do this, but perhaps the most deliberate would be give this anchor tag a unique identifier called Harvard or whatever you might want to call it. And let's do the same over here. Let's add an ID to the second anchor tag that calls this tag Yale. And I'm using lowercase by convention. What this allows me to use is yet another type of CSS selector. Not type or name, not class, but ID. I can create a unique identifier that allows me to say target the Harvard element. How do I express that? Well, instead of using a dot, I actually use a hash symbol here. And I say hash Harvard. And then inside of those curly braces, I can say color red. And I can do hash Yale. And then inside of those curly braces, I can say color blue. And actually, just to bring back memories, for better or for worse, of hexadecimal notation and Photoshop, as we discussed when we discussed multimedia and representation thereof, I can actually use hexadecimal codes. So instead of saying red or blue or any other color, I could say hash symbol here, unrelated to the hash symbol next to the class name. Now we are combining color codes with CSS. I can do this, FF0000, which is a lot of red, no green, no blue. Down here I can say hash symbol, no red, no green, lots of blue. And those represent essentially the same colors. Down here, I still want to do, I'm going to not bother actually with the text decoration anymore. Let me go back to my page here. Let me reload. And now it's getting a little prettier, a red Harvard, a blue Yale, with those two links targeted specifically. Now there's yet other ways too. A third way would be to target a element based on the value or presence of one of its attributes, aka an attribute selector. But I'll wave my hand at that, since surely you'll see eventually in documentation elsewhere, if you go down this road with web design, how you might target those as well. But we don't have to do even these selectors. IDs are meant to be unique. So maybe it would be better to say anytime I have something related to Harvard, let's use a class called Harvard. Anytime I have something Yale related, let's use a class called Yale. So here then, instead of saying ID, I can say class equals Harvard and class equals Yale. And now, even though it's not relevant for this simple example, I can use that class on a different elements again and again. An ID is meant to be unique, and it is a mistake on your part or my part if you use it in multiple places. All right, so much like with HTML, which really only had tags and attributes as its basics, similarly is CSS relatively simple in design with just these properties. And it too has a much larger vocabulary of things and features that you can use throughout your web page, but we'll wave our hand at that so that you pick up that vocabulary over time via online references or the like. But for now, let's just focus on how you can really leverage CSS to take up a notch the aesthetics of your page and make things much prettier than I myself have been doing thus far. Let me go back to VS Code and let me copy from the code I brought with me today a phone book example that gives us the simple form of a phone book with 3 people. Let me go ahead and open this file as it's already been made. And in this file here, after I close my terminal window, is this: a phone book that is apparently made up of an HTML table. Inside of that table is a couple new tags that I'm introducing for formality's sake here. One is called thead for table head, inside of which is the heading of the table with a table row, tr, with 2 th tags, table heading for short. Long story short, even though the table I made earlier to mock up the visual of a phone keypad is perfectly correct structurally, it turns out if you want to distinguish the header of your HTML table from the rest of your HTML table, you can do so by introducing thead up here and tbody down here. So implicitly, what I was doing earlier was treating everything as the table body with no fancy header up top. But what is different here is that by using th for the table heading here instead of td, it's a clue to the browser that this actually has some semantic meaning. This is the heading of the table, and maybe it, for instance, should be bold-faced by default. But we've seen already we can start to override that. As for the body of this table, it seems like it's a phone book with 3 people, Yulia, David, and John, with our now familiar numbers, each implemented in a table row. If I go back over to my directory index and reload, I'll now see phonebook.html. And even though the data's there, honestly, it's not particularly pretty, if you will. In other words, within this file here, I've got all of the data I care about, but certainly no CSS. And while I could go in and start using some selectors and adding some CSS, some key value pairs for properties to make this prettier, maybe with some borders and the like, I bet I can do better by standing on the shoulders of someone else who's made a third-party library, who's thought about what would be the prettiest way to display an HTML table. And this gives us an opportunity to discuss what are called frameworks in the world of web development in particular. A framework is really a library written by some third party that just makes it easier to frame your own project, to sort of structure your own project so that you don't have to implement a lot of basics, particularly aesthetic, that so many other people have had to deal with as well. Better to focus on the problem you actually care about, the business you're building, the product you're creating, rather than worry too much about the aesthetics thereof. And among the more popular frameworks in the world of HTML and CSS is something called Bootstrap, which is a library that anyone can use and incorporate into their websites, really by just including 1 or more HTML tags, and suddenly everything would seem to look prettier. And in fact, let me go ahead and do this. Let me copy an example I brought with me as well. This one, a second phone book example. If we open this new and improved version of phonebook.html, notice a few things. In the head of my page, I've included a link tag this time, but it's not referring to a file of my own, like styles.css from before, but rather it's referring to an absolute URL that ultimately, per the end of this URL, points to a file somewhere in the cloud called bootstrap.min.css, where min is just saying that this is a minified file, which means a lot of the white space has been deleted from it just to shrink the file's ultimate size, but it is in fact a CSS file. Meanwhile, lower down in this file, if I close my terminal window here, we'll see in the table tag that I've used a class attribute, the value of which is table. Why is this? Well, according to Bootstrap's own documentation, they just told me if I want to use their stylization, their style sheet, be sure to add a class of table to your own HTML table so that they don't presume to change the aesthetics of all of your tables, just the one to which you've added this class. Meanwhile, the documentation also advised me to add scope equals column and scope equals column to 2 of these table headings up here. But otherwise, the data itself is exactly the same. So let me go back to my browser tab here, which previously looked like this with no CSS whatsoever. And honestly, even if I'd added my own CSS, you've probably been underwhelmed as to how pretty my own pages look. Probably would not have looked much better. But simply by including Bootstrap CSS file and adding those attributes that I pointed out, notice what happens when I now click reload on this newly stylized phone book. Suddenly, it looks much better. Still black and white, so if you were expecting even fancier, you're not going to get it, but it's still black and white. But notice the font is no longer the default. It's no longer some serif font, but it's some sans serif font with less decoration. Notice that name and number have been automatically boldfaced. Notice that clearly there's more padding or spacing among all of these values, so arguably it's easier to read. Notice that there's the gray line separating each of the rows from each other. And long story short, it's just prettier. It's nicer to look at, but you and I don't have to figure out how to adjust the white space, how to adjust the bold facing, how to adjust the font size, and all of that. The library takes care of that for you. Moreover, there's other features you can include here. If I read the documentation, it turns out that I can also add table-striped to the class attribute. So we haven't seen this yet, but it turns out that the class attributes value can be one word or two or three, so long as they're separated by spaces. So if I read the documentation, turns out I can apply two classes to this table, the second one now being table striped, and watch what happens when I now reload the page. I now see that every other row is very beautifully striped. Slightly more usable, slightly prettier to look at, and maybe more helpful then to discern what data is on what row. And let me wave my hands at the rest of this, but suffice it to say that by way of frameworks like Bootstrap, you can actually make your website faster and better and prettier without having to reinvent lots of wheels yourself. That said, if you're particularly artistically inclined and want to fine-tune things, you can create some or even all of the CSS that you're using. But for more on Bootstrap, all of its documentation is at this URL here. And in fact, in many of CS50's own projects, do we ourselves use Bootstrap and its classes so we don't have to figure out all of the aesthetics thereof. Now, with all that said, just one language remains, this one a proper programming language that, for better or for worse, is going to bring back functions and arguments and loops and conditionals. But before we get there, let's take a 5-minute break. And when we return for the final time, we'll dive into JavaScript. All right, we are back, and we now take a look at the third of our 3 languages today, that of JavaScript, but specifically one that's a programming language. And by programming language, I indeed mean that we'll get functions and arguments and loops and conditionals and more back. But let's take a quick tour through JavaScript, just as we did Python, much more quickly, because what's ultimately important to us today is that you have a sense of what JavaScript can do, but we will really only scratch the surface of this here language. Not only can JavaScript be used in some of the ways we'll see today, but it's also increasingly being used on the server as well to generate entire websites and applications and more. So we'll give you a sense really of some of the basic syntax and basic capabilities, but ultimately defer to your future endeavors, your own final project perhaps, to apply JavaScript and explore it all the more. So just as we did earlier, let's consider the simplest of web pages here in HTML alongside its own DOM, or document object model, which represents, again, how that HTML might be structured in the computer's memory once the page has been downloaded and loaded by the browser. Unfortunately, what you're looking at here is a very static web page, one that simply says hello title and hello body. But wouldn't it be nice if that DOM could evolve over time? After all, in C and then in Python, we experimented with data structures via which we can add and remove data dynamically based on user input and more. In fact, almost any web page you've used nowadays has some form of dynamism involved, such that it's rare for it to be a static website. Odds are something is changing. Case in point, if you open up your Gmail inbox or Outlook inbox and just sit there staring at it, odds are, for better or for worse, more email will appear. More email will appear. And previously, we described those kinds of inboxes as stacks, which they rather are underneath the hood. But visually, how are those stacks of emails being implemented in HTML? Well, we've seen already that it's probably some form of tabular data, a bunch of TRs, 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 one for each email that you might receive. But if it's coming from the server once, how can you possibly get more emails? So long story short, thanks to server-side technologies, Python among them, and client-side languages like JavaScript among them, can you actually, behind the scenes, get more and more data from the server in order to update the web page and in turn the underlying DOM. So how can we go about doing this? Well, let's see what some of the things are that JavaScript can do. We have conditionals in JavaScript, whereby, such as in Scratch, when we had x less than y as a Boolean expression, in JavaScript here at right, that kind of code is now going to look like this. Unfortunately, the parentheses are back, the curly braces are sometimes back, but this is perhaps the simplest way to think about the structure of a JavaScript version of a conditional. It actually looks, at a glance, exactly like C. If we consider an if-else in Scratch here, right now with JavaScript would be exactly the same, just as we saw, in fact, in C. And similarly, if we have an if, else if, else if, that too might look exactly like this. But unlike Python, which rather abbreviated else if, in JavaScript and in C, it is else if with a space in between. All right, what about variables in JavaScript if you actually want to be able to store something in your own variables? Well, in Scratch, recall that we might have set a counter equal to an initial value of 0 like this. In JavaScript, there's a few ways to do it, but the simplest way to describe this is by using a new keyword, let, which is like a very polite way of asking the browser to give you a variable. Let me have a variable called counter and initialize it to a value of 0. Semicolons, though, are now back. Now, that's a bit of an overstatement because JavaScript can actually tolerate the absence of semicolons, at least in many cases. However, for consistency, we and I will continue to use them here. How about if you want to increment that counter by a value of 1? Well, in JavaScript, you can do this by setting counter equals to counter plus 1, the equal sign being, of course, our assignment operator from right to left. You could also do counter plus equals 1, just as in C and in Python. And if you like this in C, plus plus and minus minus are now back. So in JavaScript, you can do that to increment or decrement a variable respectively. What about loops? Well, in Scratch, we might have had something like this to repeat 3 times. In JavaScript, it similarly is going to be very similar to C. But instead of saying something like int for integer in C, we indeed say let in JavaScript to create a variable like I. Do this, say, 3 times while incrementing with plus plus I along the way. What else might we now do? Well, we might have a forever block here in Scratch that does something, of course, forever. In JavaScript, you can also say while true, where true is back to being lowercase here. And that will ensure that whatever's between those curly braces will happen again and again. Meanwhile, if we revisit the canonical form of this HTML, where can we actually put JavaScript code? Turns out there's a few different places, and there's a few different reasons to use one place or another. But just so that you see in the range of possibilities, especially when you then see suggestions in online documentation for JavaScript libraries, you can put a script tag in the head of your page, just like we put a style tag or a link tag up there as well as the title. And inside of that can go some raw JavaScript code typed out by you. Of course, I've proposed that it tends not to be ideal to commingle one language with another. And so there's other ways to do this too. You can actually have a script tag, this one with a source element that will allow you to specify another file name or even another URL from which you want the JavaScript itself to come. What's a little weird, though, about the script tag here, even when used with a source attribute, is that you'll see that I've closed the tag nonetheless with an open bracket / script close bracket tag at the end of this line to make clear that there's no JavaScript inside of this element. Indeed, it's only coming from that same source. As an aside, you will also see, and there are also reasons to, sometimes put a script tag in the body of the page that is below most everything else in the page, or a script tag with a file reference therein even at the bottom of the page, just because order of operations can indeed matter. But these are sort of subtleties that we'll try to avoid for now, simply focusing on really what JavaScript itself can do. And in fact, what's perhaps most powerful about JavaScript, and what nicely brings us rather full circle back to where we started the class in Scratch, JavaScript, in the context of browsers, can be very much event-driven. So just like in Scratch, when we actually had actual events, and even a block, if you discovered it, called broadcast, where you could have one sprite somehow signal to another, in JavaScript, and specifically in the context of browsers, there's just so many events or things that can happen. For instance, you might change the value of a field in a form. You might give something focus by clicking on a text box. You might drag something from one place to another. You might put your mouse down or mouse over something. On a mobile device, you might put a finger down, thereby touching down on the device. So long story short, all of these keywords that you see here represent events that happen inside of a browser that JavaScript as a language can be used to listen for and respond to. And as such, you can use JavaScript to make very interactive and responsive web pages, whether that's to go get more emails from the server or to grab more of a map if you're clicking and dragging while using Google Maps or the like. So let's begin to scratch the surface today only of what JavaScript can do. Let me go back to VS Code here. And let me create a new file here called hello.html. And in that file, I'm going to go ahead and save a few steps by first copying as a starting point some of my earlier code. Let me close my terminal window, change my title as always to just hello, and get rid of now that default body. And let's go ahead and whip up a very simple interactive page that just says hello to someone more interactively, ideally letting them type in their own name, just as we've done in so many languages prior. Let me go ahead and create a form tag in here. And inside of that form, let's give myself an input. And just to practice what I've been preaching, let's turn autocomplete off as before. Let's turn on autofocus so I don't have to click in it manually. Let's give this input a unique identifier for reasons that we'll soon see, like name, although I could call this thing anything I want, but I do want the person's name. Let me use the placeholder text of name so it's clear to the user what I'm prompting them for. And the type of this text box, even though this is the default, shall indeed be text. What else do I want to do? Well, let's keep it simple and just have an input type equals submit so that I get a button, which you've seen in a couple of different ways. Let me go back to my other tab, reload the page, and I'll see now hello.html. Inside of this file, I see a very simple form. If I type in my name, though, and click submit, notice that my URL has changed. If I zoom in up here, and there's indeed a question mark, which suggests that something was submitted from the browser to the server, but there's nothing after that. There's no something equals something. And why is that? Well, even though I gave the text box an ID of name, I didn't give the text field a name itself. In other words, I did not say, if confusingly, name equals quote unquote name, just as I did name equals quote unquote queue or name equals quote unquote email. And that's fine, because we've certainly seen inputs before that don't actually send anything to the server. They just result, for instance, in the case of a button, in the form itself being submitted. So this is to say that if an input in a form does not have a name, it's simply not going to be submitted to the server. But that's OK, because my goal at hand today, at least for this example, is to say hello to the user, but not server side. We don't yet have the means yet, until we reintroduce some Python to generate content server side. I want to do everything client side. And so just to be clear, just as HTML is downloaded from the server to the browser, CSS is downloaded from the server to the browser, JavaScript, as we are currently using it, will also be downloaded from the server to the browser and executed client side in your own Mac, your PC, or your phone. Which is to say that any of the data we get from the server has to come all at the get-go. Until then, it gets executed client side. So if I want to greet the user based on what they type in their name as, I need my client-side JavaScript code to go grab that name from the form and display it on the screen for me. So how can I do this? Well, it turns out that the form element can take another attribute that we've not yet used that's actually reminiscent of those keywords on this list here. Indeed, notice on this list is a submit event. And indeed, in HTML, I can use an onSubmit attribute in my code to do most anything I want. For instance, suppose I want to call a function. I'm going to call a function called greet. However, I don't want this actual form to be submitted. I actually want to return false here as well after a semicolon, just to make clear that what I want this form to do is no longer to submit to the server, but rather greet the user by calling some function called greet, and then return false. And return false, per the documentation for how browsers and JavaScript works, just means that the form never goes to the server. So how can I go about using this here code? Now, this greet function doesn't actually come with JavaScript, but I can create it myself, just as I could create functions in Scratch, in C, and in Python. In fact, let me go up to the head of the page and keep things simple, create a script tag in there above my title, and then inside of that script tag, let's go about defining a function in JavaScript. It's a little different from C, it's a little different from Python, but the end result is really the same. In JavaScript, you literally write the keyword function, which means, hey, browser, here comes a new function. You then give that function a name. I'll call it greet. You then specify in parentheses whether or not that function takes any arguments. And for now, I'm going to say no, none. And then inside of curly braces, I can implement the actual function. Well, what do I want to actually greet the user with? Anything for now. Let's keep it simple. Let's actually use JavaScript's built-in function called alert and just say something like, how about hello, comma, world, close quote, semicolon. So the alert function, unlike greet, does come with the language. Here, I'm going to go back to my browser, reload the page, type in DAVID, and now I'm going to click submit. And notice what happens. I now get a fairly ugly pop-up, which is built into the browser itself, but toward the middle of it, it indeed says hello, comma, world. Now, that has nothing to do with the name I typed in, but we can fix that. Let me click OK. Go back to VS Code. And before I say hello world, let's do this. Let's create a variable called name and set it equal to the following function, though it's admittedly a mouthful. Document dot query selector, quote unquote, hash name dot value semicolon. There's a lot to unpack here. So what's going on? Well, recall that from Python, you can chain certain things together. And recall from C and Python, you can use the dot operator to go inside of structures or objects. So that's a lot of what's going on here. So it turns out there's a special global variable when using JavaScript in a browser called document, which refers to the document itself, the DOM, if you will. And if you go inside of the document, it comes with a method, aka function, called query selector, capital S, lowercase q. And what query selector lets you use, funny enough, is the exact same syntax that CSS uses to select elements. So you can select elements in the page by way of their name or type, like body or header or main or footer. You can select elements by way of classes or by way of their IDs or other techniques as well. Now recall earlier that I did give this HTML input an ID of quote unquote name. And so if I want to refer to that ID, recall from CSS that the symbol is the hash symbol and then the name of that identifier. So what's happening here is I'm saying go into the document, use the query selector method, look for the element whose unique ID is name, and please grab its value. That is whatever the human typed into that input, and store it from right to left in a variable called name. Now all I have to do is include it in my alert to the user. And just as in Python, there's different ways to do this. What I'm going to go ahead and do first is our old friend, the plus operator, after a space inside quotes, and append to or concatenate to hello, comma, space, that person's name. Now notice too, what I've deliberately done here is the following. In the world of C, double quotes are what you use for strings and single quotes are what you use for characters. In the world of Python, double quotes or single quotes can be used for strings, otherwise known as strs. In JavaScript, same thing is true. Double quotes or single quotes. I will say conventionally, probably most JavaScript programmers use single quotes for better or for worse for strings. So that's the habit I'm going to adopt here, if only to be consistent with that. Let me now go back to my other browser page, reload, type in again my name, David, and notice now when I click submit, now I get, if I zoom in, hello, comma, David. So I've created a string there dynamically. Notice too, once I dismiss this by clicking OK, if I go back up to the URL bar, notice that I have not actually submitted the form. No question mark, no key value pairs have appeared in the URL. All of this is indeed happening client side. Now, what more can I now do with this? Well, this arguably is not the best design because as before with CSS, I'm kind of commingling one language with another. And I've kind of baked into my HTML some very explicit JavaScript code. Can I get rid of this? Well, I can in fact do that in a couple of different ways. Let's go ahead and do this. Let me go ahead and get rid of the onSubmit stuff, leaving therefore just the form and the two inputs inside of it that I had previously. Just to avoid a problem, let me go below this now and add a script tag after getting rid of this one up here. So I'm going to deliberately move everything to the bottom of the page for now, just so that this works without creating a problem. And what am I now going to do? Well, it turns out in JavaScript, you can actually use JavaScript to query the DOM for specific elements and then listen to events that might happen with those elements. You don't need an onSubmit attribute. You can do all of this in code. So how might I do this? Well, let me do this. Let me create a JavaScript variable called form, set it equal to document.query selector, and then let me go ahead and select the one and only form in my page with quote unquote form. I don't need a hash symbol. I don't need a dot because I'm selecting that element by its type or its name, which in this case is form. All right, what can I now do with this variable? I can now use form dot and a new method that we haven't yet seen. It turns out in a web page, once you have a variable or some other value that represents an element on the page, you can call a method called addEventListener. And as the name implies, that allows you, after the page has been created, to start listening for some special event on that element. That event being drawn from a list like this one here, including the submit event. So how can I do this? Well, this function takes one argument, which is quote unquote the type of event that you want to listen for. And I could listen for any number of things, but the one that's relevant for a text box in this case, or one that's relevant for a form with this text box, is going to be quote unquote submit. And then I can call a function that actually gets called whenever that form is submitted. Now, greet, again, does not yet exist because I deleted it earlier. But notice what's happening here, which is not something we've done much before, except a little bit in Python. I am calling the form variables add event listener function, aka method. I'm telling it to please add an event listener on the submit event. And whenever that event is fired or triggered, please call this function greet. So I'm passing in the name of the function. I am not using parentheses after the name of this function because I don't want to call greet now. I want to register greet as an event listener, so to speak, so it's called later by its name by the browser for me. Now, how can I go about implementing greet? I can do something as before. So above this code, so before I use it, let's say function greet, open paren, close paren. Then inside of this function, let's do something similar to before. Let name equals document.query selector, quote unquote, hash name to get at the element with that unique name, with that unique ID, dot value. And below that, let's go ahead and use our alert function saying again, hello, comma, space, plus, to use the concatenation operator, that particular name. Now, there's one other thing I do want to do here, because by default, when forms are submitted, they indeed get submitted to the server. But that's behavior that we wanted to preempt. The way we prevented that last time was by adding return false inside of the event handler. But there's actually a better way to do that. It turns out that when adding an event listener using a function called greet, you're actually going to be passed in an argument, whether you want it or not, that I can refer to as event, or E for short, but I'll be more explicit with event. And it turns out that that argument that gets automatically passed in for you whenever that event is triggered allows you to call event.preventDefault, which is a more programmatic, less hackish way than previously, whereby I just returned false. This is literally telling the browser, when you get this event, let me do my own thing by alerting the user, hello so-and-so, but prevent the default behavior, which we know now to be submitting the form itself. So if I haven't made any mistakes here, and I go back to my browser, reload this page, type in DAVID again, and click submit, there we have it again. The browser has shown me hello, comma, David. But this is getting a little verbose, honestly. And in fact, there's more JavaScript-like ways to do things like this. And let me propose to do this. Notice that I am, one, using a variable called name here, and then only using it in one place. That's totally fine and very reasonable. But we know from C and Python that's not strictly necessary. So if you're more comfortable, you can get rid of that whole variable, like such, and then just concatenate to hello, comma, space, the return value of that same function. Now, this fits on the screen nicely. It's still pretty readable. I would wager that this is reasonably well designed. But if this line of code got much longer, we probably do want to go back to the version with an actual variable. But we still want to prevent the default. But what about this line here? Notice that I'm calling a function called greet, even though I'm only doing that once. So we can actually do something in JavaScript that's kind of neat that we can't quite do in the same way in C or in Python, at least not nearly as elegantly. It turns out that if I'm only using the function greet once, I don't really need to give this function a name. In fact, let me just kind of get rid of that there and get rid of this here. And let me propose this. This will look ugly at first, but I'm going to grab this whole function and I'm going to literally copy and paste it as the second argument to add event listener. I'm going to go ahead and clean it up a little bit to be a little conventional here. I'm going to move my curly brace to this line. I'm going to get rid of this space. But now, this is actually pretty compact. Let me get rid of some of the blank lines. And notice what I'm now doing. I'm still using a variable called form to get the one form in the page. I'm then telling that form to add an event listener for the submit event. But because I want to tell it what function to call, what you can do in JavaScript, which you can actually do in Python too, is you can pass in an anonymous function, otherwise known as a lambda function, that still might take an argument but does not need a name. Why? Because if you're using it only one place, why bother even giving it a name? So the only thing I've done is I've deleted the name greet and simply calling it function and then passing in specifying the argument it should take. But the next two lines are exactly the same. And the only thing you have to be careful about is, notice I've got the closed curly brace here, and then the closed parenthesis, the first of which closes this curly brace, the second of which closes this first parenthesis. And if you really want to tighten things up, we don't really need the form variable. Let me get rid of that line of code and change that variable to be this one-liner. And so even though this is getting a little complicated visually for those unfamiliar with JavaScript, this is fairly conventional syntax for doing a whole lot of things at once in this particular language without unnecessarily using variables and the like. Now, let me demonstrate that still this here works. If I reload the page and type in my name, David, and submit, we do get that pop-up. But let me do what I did previously, which was to put this whole script tag inside of my head tag at the top of the page. So I'll make room for it up there. Same exact code, but now the script tag is above the form tag. Let me go back to my browser here, click reload, type in DAVID, and click submit. And dang it, we're somehow back to the broken version, where still my name, because I added that name attribute earlier, is getting submitted to the server, but I don't want this getting submitted to the server. What is now going wrong? Well, let's see if we can't diagnose this. Let me go back. Let me right-click or control-click and inspect and show you one final tab today, which is that of the JavaScript console. It turns out that in the console tab of your developer tools, you can see error messages from languages like JavaScript. And if you see anything red like this, odds are, I'm afraid, you messed up. Or in this case, I messed up. And let's see if we can infer what's wrong. Cannot read properties of null reading add event listener. Unfortunately, just like Clang, just like Python, the error messages in the computer world are not always that clear, especially for first-time programmers. But it at least seems to relate to line 7, character 43 of hello.html. So let's go back to this line here. Line 7 here is in place. Why might the form be null? Well, notice that this global variable here is referring to the whole document. Query selector is selecting some element from that document. But if that element doesn't yet exist, this function call here, which I've highlighted, will return null. So this is kind of like saying null.eventListener, which just like our time from C, kind of makes no sense. You can't dereference null. You can't do anything with null. So something has gone wrong. Now, why is that? Well, much like Python, much like C, these languages are typically read top to bottom, left to right. And unfortunately, if you define the form on line 16, but you try to access the form on line 7, it's just not going to work. And so what you're seeing in JavaScript's console here is that it's null because it hasn't yet been read. Now, previously, I avoided that problem by moving the whole script tag to the bottom of the page, just sort of avoiding the problem. But there is another way to do it. And you'll see in lots of libraries, even though it's a bit of a mouthful. Let me go into hello.html here and add one more event listener, which I'll type out myself. Document.add event listener. And I'm going to listen for a very special event that you have to capitalize just right. DOM content loaded, quote unquote. And then I'm going to go ahead and call another anonymous function that simply does all of this stuff together. At the very bottom of what I just added, I'm going to add another, I'm going to add the close curly brace and another close parenthesis to now close this curly brace up here that I just added and this parenthesis here that I just added. So this too is more of a mouthful, but what is DOM content loaded? I mean, it kind of does what it says. When the DOM's content, the entirety of it has been loaded, then can you go ahead and execute these lines of code. How do you know what lines of code to execute? Well, here too, I've defined an anonymous function in JavaScript, which just allows me to contain inside of these curly braces the lines of code that I want to execute. Not now, but eventually, when the DOM's content has loaded. So this is to say that even in these simplistic examples we've seen already, JavaScript very heavily tends to use these anonymous functions. Or really, people who write JavaScript code tend to heavily use these anonymous functions, if only because it tightens things up. And typically, once you have some experience with programming in this or other languages, you'll get more and more familiar with this. Even though at a glance, for the first time, this admittedly looks way more complicated than the problem it's actually trying to solve. Now, that said, just like with CSS, we can get rid of all of this stuff. Let me highlight and cut that out. Let me delete all these new lines. Let me go into my script tag, and let me pretend for the moment with a source attribute that I have a file called scripts.js. And I could imagine now going into a file called scripts.js, pasting all of the code I just cut out of this file, and then just like CSS, allowing one file to refer to the other. So in other words, you can ultimately go ahead and implement that same paradigm of separating one language from another in JavaScript as well. All right. That was a lot, but let's now focus not so much on writing as much code like this, but looking at some examples that I brought with me to demonstrate what more we can do with JavaScript. In my terminal window, let me go ahead and grab a 5th version of this file from my source8 directory. That's going to look a little something like this. In hello.html now, which I wrote in advance this time, we have some very similar code such that I'm listening for the DOM content to be loaded. I am defining a variable, in this case called input, because I wanted to find a textbook on the page. And I'm using another event listener. And we've seen it on this here list, not just submit, but for instance, key up, when the human's finger comes up from the keyboard just after having typed something. Let's see for the moment, before we dive in further to how this event is being used, what this page now looks like. If I close my developer tools and reload the page, notice that the submit button is gone, but I still have a text box. And watch what happens when I start typing like the letter C, or A, or T, or if I delete, W, O, R, L, D, delete, and then there's a default value here as well. So notice now it's sort of automatically updating the DOM of the page as I'm typing. In fact, let me do this. Let me reopen my developer tools with inspect. Let me go to the elements page by default, and notice the P tag here. At the moment, in the browser's memory is the phrase hello, comma, whoever you are. Let me start to type my own name now instead of cat or world or anything else, D. And notice that not only am I seeing hello, comma, D on the screen, notice that the DOM, as represented by the Elements tab, has been dynamically updated as well. If I type in now an A, notice what happens in both places too. The DOM gets updated again. VID, notice that, and it's flashing to draw your eye to it. I'm updating the DOM in memory. Meanwhile, if I close this and open up the page source, recall that this is a static version in here. There is no mention of DAVID in the actual HTML. That's coming from me, the user. So if we go back now to VS Code, let's look at how this works. Again, on line 10, I created a variable called input that just uses query selector to find the input element, the text box. Then I registered an event listener on that text box for key up. So this thing responds as soon as the finger comes off the key. I want this function anonymously to be called whenever that key goes up. I, inside of this function, define a variable called name, and I use the query selector to get another element on the page called P. Well, where did that come from? Well, let me open the page source again. And notice at the bottom of the page is not only the form, which is super simple, no submit button even, but there's also an empty paragraph tag that I just put there as a default element to fill with my content. Let me go back to VS Code here. And notice that once I've got that, I've got room for the person's name. So what I'm going to do is this. If the input has a value, if the text box has something typed in, I'm going to do this. I'm going to go inside of that name, the so-called paragraph. I'm going to change its inner HTML. Capitalization is important here. Lowercase inner, all caps HTML. And I'm going to change it to be hello, comma, something. More on that in a moment. Else, if there's no input value, that is, it's blank, so this Boolean expression is false, let's just change the inner HTML to be hello, comma, whoever you are. That's the default value. The last thing to tease apart then is what is going on here. This is horrible to look at, I will admit, and is the ugliest of the syntax we've seen. But just like in Python, we have those format strings or F strings where you can put the F and then quote marks, and then curly braces inside to interpolate the value of some variable. JavaScript has something similar, except it's much more ugly to look at. Specifically, you use backticks, which vary in their location based on whether you have a US English keyboard or something else, but a backtick at the beginning and a backtick at the end. And inside of those backticks, if you want to interpolate the value of some variable, you do use curly braces, but you also use a $sign. So it's like Python syntax, but worse. But it's the exact same idea. There's nothing really complicated beyond that other than remembering or Googling the syntax for that technique. So at the end of the day, the result is that we get this sort of automatically updating page that updates one keystroke at a time based on what the user typed in, this time based specifically on the key up event instead of submit. Well, let's do one other. Let me go back to VS Code here, open up my terminal after closing hello.html. Let me copy from my source directory today something called background.html. And now let's go back to my directory listing here, reload, and see background.html and click it. This is very simple, but let's see if we can infer how this works. I've got 3 buttons, and they're not rectangular as much as they are square, but that's just because the labels R, G, and B are so short. But watch what happens. R turns my background red. Green turns it green. B turns it blue. Well, how is that happening? Well, let me go back to VS Code here, and let me actually open now this file, background.html, and notice what's going on here. Inside of my body, I've got 3 buttons, each of which has a unique ID, red, green, or blue, and each of which has super short labels, R, G, and B, in all caps. But then I have a script tag. Notice first I'm creating a variable called body that's just grabbing the element from the page, the type of which is body, and there's only one of those. And then notice this. I've got 3 nearly identical lines of code starting here. I'm going into the document using query selector to find whatever element has a unique ID of red, per the hash symbol. On that element, I'm adding an event listener for the click event, which is, again, on our list of events that you can listen for in JavaScript, in addition to submit and in addition to key up. Here, then, I'm listening for click, and I'm calling this anonymous function when that R button is clicked. And when it is, I execute one line of code. And here's where today kind of comes together in full circle. I can, inside of my web page, using JavaScript, modify the CSS of my page too. I can go into that body element, access its style attribute, which is a variable inside of the body, and that exists because that's how browsers work. And I can access the background color property inside of that body tag style. It's like accessing its style attribute, if you will. And I can set it equal to quote unquote red. Or I could do hash ff0000, but I kept it simple with quote unquote red. The next 3 lines of code are the same thing, but for green. The last 3 lines are the same thing, but for blue. The only thing that's weird here is where did background color come from? Because it's lowercase b and capital C. Unfortunately, this is maybe not the best design historically. In CSS, we saw text align, we saw color, we saw a couple of other properties as well. Unfortunately, there is in CSS a CSS property called background-color. I just didn't happen to use it just yet. Unfortunately, CSS uses background-color. JavaScript necessarily uses background color with capital C. Why? Well, in JavaScript, you can do math, like in most languages. And unfortunately, the dash is already used as a minus sign. So unfortunately, in JavaScript, if you wrote this property as background-color, this would be like trying to subtract color from background. So background minus color, which makes no sense. So left hand and right hand weren't really communicating, it seems. So the solution was just to use camel case, so to speak, like a camel with a hump, and capitalize the C, but get rid of the hyphen. And there is a mapping, therefore, from CSS properties to JavaScript attributes in this way. So that's all that's happening. And in fact, we can see this again in our inspector. Let me reload the page to go back to white. Let me again open up the developer tools. Let me click on the body of the page, which currently has no attributes. And at right, there's no styles being applied to it other than the defaults from the user agent style sheet. But watch what happens now under element.style and on the body tag itself. When I click R, a style attribute will suddenly appear programmatically on the body tag with a value corresponding to background-color : red. Notice over at right here, too, we see a summary in Chrome's developer tools of exactly that. If I click on G, if I click on B, I can see exactly the same thing happening for each of those colors. So here now, we have the ability with JavaScript not only to alter the DOM of the page, the contents of it, what the user is seeing, but also, it would seem, the CSS thereof. What more can we do? Well, let's look at one other example that sort of evokes a tag from yesteryear. Let me go into my source directory and grab an example called blink.html and show you in this code herein. If I hide my terminal window, we've got a function in this file inside of my script tag called blink, which apparently toggles visibility of greeting. But what does that mean? Well, let's try to infer here. There's a variable called body, which is set equal to the return value of query selector. And we're checking this question. If the visibility of that element is hidden, then change the visibility to visible. Else, change the visibility to hidden. Now, this too is one of these left hand and right hand. We're not intercommunicating. I have no idea why the opposite of visible is not invisible, but the opposite of visible in CSS is hidden, for better or for worse. So what's really happening here is we have a conditional, an if-else construct, that's saying if the visibility is hidden, make it visible, but if it's visible, make it hidden, back or forth. How is this being used? Well, here is another function that comes with JavaScript. There's a global variable called window, which refers to the browser window itself. That comes with a method called setInterval, capital I. That function takes two arguments, the first of which is the name of a function to call. Notice again, not using parentheses, because I don't want to call blink on line 22. I want to pass the name of that blink function to this setInterval function. And 500 is the second argument. That refers to a number of milliseconds. And what setInterval does, as you might imagine, is it will now call the blink function every 500 milliseconds, or half a second. So the effect, if I go back to my browser tab, close my developer tools, and click now on blink.html, is a resurrection of a tag that actually existed when I was growing up, whereby you could literally do open bracket blink, close bracket, and you could make your web page's text blink like this. Even worse, there was a tag called marquee that would scroll your text across the screen, very hideously so. And in fact, among all of the features of HTML, among the few that have been removed over the years are exactly those two tags. But with JavaScript, we can bring them back now in this way. The point of which really is to demonstrate, again, how much control we now have over over our DOM and our web pages thanks to JavaScript. Let's do one final example here. Let's go back to VS Code here, open my terminal, and let me copy in one last file from today's distribution code called autocomplete.html. And let's go ahead and open up autocomplete.html here in VS Code. Well, what's going on here? Well, it turns out that there's a body of this page which just has a text input that's of type text with a placeholder of query. Below that, there's this empty unordered list with nothing initially, much like there was an empty paragraph tag previously, so I could put hello so-and-so. Then there's this file here using a script tag referencing large.js. So I actually need that file too. That's in today's distribution too. So let me grab large.js, which, if we open that up, might look somewhat familiar. It is a JavaScript version of the dictionary from problem set 5, wherein you implemented the fastest spell checker that you could. So there's 100,000 plus words in this file. But notice they're structured as a JavaScript variable called words, all caps, to make clear that I mean for it to be global. It's using square brackets as on line 1, because that, it turns out, much like Python, is how JavaScript indicates an array. But in JavaScript, they're again called arrays instead of lists. And then I just have this comma-separated list of strings using double quotes, but I could have used single quotes for all 100,000 plus of those words. So by including this file, this means that my script down here has access to that words variable. What am I doing? Well, I'd create a variable called input and set it equal to query selector's return value, just so I can get a variable pointing to that text box. Then I'm, again, as before, adding an event listener, listening for key up, so the finger coming up. And whenever that happens, I call this anonymous function. I first, in that function, set an HTML variable to quote unquote, so the empty string, nothing. Because what I want to do is build up a list of words that match whatever the human has typed in. And you'll perhaps see where this is going in a moment. If the user then has typed something in, there's a value in that text box, do this. Iterate over that array of words. So for each word of words. Here, too, is a JavaScript-specific feature, but it's similar in spirit to Python, sort of similar in spirit to C. But the preposition I'm using is indeed of. And I'm saying for each of the words of this words array, it's a little weird, the English, but this is how you can iterate over every element in a JavaScript array. If the current word that we're iterating over starts with capital W, so this is a function that comes with strings in JavaScript, that input value. So in other words, if the word we're looking at in the dictionary starts with the same letters that the human has typed into the text box, let's do this. Let's concatenate onto the HTML variable, which is just an empty string initially, the following HTML. Now this too looks weird, but remember that the backticks mean that you can interpolate variables inside of curly braces. So this means add to that HTML variable another li tag and another close li tag, inside of which, though, is the word that has matched the first few characters. And do that again and again and again. And plus equals here just means concatenate, concatenate, concatenate. So we're essentially building up in JavaScript more and more and more and more HTML dynamically based on the human's keystrokes. And the very last thing I do is this. I ask the document to query select the UL element, which previously was an empty unordered list, but change its inner HTML to be equal to the li tags that I've been creating in one big variable. So if I go back over to VS Code here, if I go back to my browser tab here and click back, and I now go into autocomplete.html, as the name suggests, this is the essence of how autocomplete exists in Google, in Bing, and in applications more generally on the web and in some mobile devices. If I type in C, I see now an unordered list of all of the words that start with C in this dictionary. If I type A, nothing seems to happen, but that's because the list is so long. If I type CAT, now notice I get every word that starts with CAT. If I type in S, now I get just 4 words, including ketchup at the end, that starts with CATS. Meanwhile, if I open up the web page's source, notice none of those words are in there. They're in the large.js file, but not in this page. If I instead close that and open up the inspector again, and I go to the Elements tab, and after having typed in cats, notice there are indeed 4 li elements there. But watch what happens. As soon as I delete mention of cats here, all 4 of those li's disappear. And now I'm back to the UL alone. So this is to say, with HTML, we can structure our web pages. With CSS, we can stylize our web pages. And with JavaScript, we can dynamically update and modify our web pages. And via JavaScript, can we therefore implement applications like Gmail and Google itself and CS50.ai and so much more, because it makes what's otherwise a very static experience in the browser suddenly dynamic. And indeed, what JavaScript can even do is make more HTTP calls to the server to get more and more data, more and more tiles from a map, more and more emails from the server. But today, we've seen just the fundamentals. Through your coming problem sets and perhaps final project, where you have an opportunity to apply all 3 of these technologies together to build the web applications and the mobile applications that you and I already use every day. That's it for CS50. We will see you next time.